There are many ways to make money online, and one way is to sell your knowledge. Maybe you have deep expertise in a certain topic, or you just have a unique perspective. So you decide, you know what, I'm gonna write a book, film a video course, or do both. Then you go to a course hosting platform and you upload your content, and then you start selling. Now, this approach works. However, as developers, we always get this urge of wanting to build our own solutions. This is me acting on this urge. Now, to not fall into the trap of building my own course platform and never releasing my course, I give myself a deadline, 1 weekend. 1 weekend to build the following features. Users should be able to view free content on my website. This way, they can be familiar with my style and know what to expect with every piece of content that I publish. They can also see the landing page for my course, click buy, which redirects them to a checkout page where they can enter their credit card info. They can then use the same email that they use during checkout to log in into the platform and to view protected content. Now, to build this project, we'll be using a lot of tools. The first one is Next.js. Now, in case you don't know what Next.js is, it is a full stack framework that has a fantastic developer experience. It allows you to build your front end using React and makes it super easy to build your API. It has a file-based system router, so each file in the pages folder is automatically a route. There's also support for dynamic routes. So for example, when you're building a blog, you want a page that shows each individual post. Now you can have a page that displays different content depending on the URL params, which is super neat. Now to build your API using Next.js, each file in the pages/API folder is automatically an API endpoint. What's also cool is that when you deploy Next.js, each one of those endpoints is automatically a serverless function. So this way, you can scale your app very easily without you needing to do much work. Now, the final feature that we'll be leveraging when building this course platform is static generation. Next.js supports different data fetching strategies. You can fetch data at build time. So this way, you can serve your users just static HTML, which is super fast and can be cached. There's also server-side rendering. So with each request, the page gets rendered on the server and then sent back to the user. This is great for SEO. And you can also do client-side rendering. So maybe you have a page where, it's not super important for data to be kept up to date. Maybe it's like an admin dashboard. It's fine if you just show some loading spinners. Now, for the course platform, we'll be kind of leveraging all of these depending on the type of page that we want to display. So yeah, but the main focus is on static generation. Now, since I have control over my platform, I don't just want a regular blog. I want a blog with interactive components. And this can be done by using MDX. MDX is the markdown for the component era. It allows you to embed JSX code in your markdown files, and this JSX actually gets rendered. So you get the awesome authoring experience of writing markdown, but at the same time, you can have interactive components in your blog posts. Maybe it's a data visualization or a component where, readers can tweak values. Like, the possibilities are endless. This can help you craft a better user experience where they can develop a deeper understanding of a certain topic or help you communicate your ideas better. Now, to add support for MDX, I'll be using Next.mdx Remote. Now, the way it will work is that I'll have a folder in the root folder of my project. It's called content. And inside it, there are two folders. One that will contain the public posts, so like my blog, and another folder that will contain the lessons that will be behind the paywall, where users have to pay so that they can log in, so that they can view them. Now, in the pages folder, I have a file called blog.tsx, and this file is responsible for rendering the page where I'll be displaying the list of all blog posts. So the way it works is I'm using getStaticProps, and I'm just fetching all posts from the file system, and I'm passing them as props. And then what I'm doing is just mapping over all the posts and displaying them one by one. So I'm showing like the title, the description, and then the categories. Now for the individual blog post, the logic is actually almost the same. I'm using a dynamic route. So I have a folder called blog, and inside this folder, there's a slug.tsx file. And in this file, I'm also using getStaticProps, but the difference is I'm grabbing the slug from the URL params and then just, getting the data for the requested blog post. And this way we have just a blog. This blog is just public right now, and anyone is able to just view the content and is built using MDX. So we can embed here just React components if we want. Now, when it comes to styling, there are a lot of options out there. You can use CSS files, you can use Sass, you can use a CSS framework like Bootstrap, you can use CSS and JS like stock components, or you can use a utility-first framework like Tailwind. Now, personally, I'm a big Tailwind CSS fan, and in case you're not familiar, here's how it works. You build your UI by combining utility classes. Now, a utility class is a single-purpose class that just does one thing. So for example, you can have a class that adds margins, a class that adds border radius, a class that adds box shadow, and just so on and so forth until you just cover all CSS properties. There are many. Now, in the beginning, my experience with Tailwind wasn't smooth at all. I've been using CSS and JS for a while, and just seeing how Tailwind works was like, oh, I need to learn a lot of stuff, and like, they're ruining my HTML. But after I've actually, gotten used to the API, I've gotten so much more productive. And this is for multiple reasons. So the first reason is I don't need to worry about naming classes anymore, because sometimes I just sit there thinking, okay, how should I name my classes? Also, onboarding is just, there's no onboarding. So if I see a project that uses Tailwind, I can just immediately contribute because I'm familiar with the API. There's a convention. And the final thing, and to me, this is just one of Tailwind's best things, is that it has great defaults. So out of the box, you have a design system. This means you have consistent values for things like margin, padding, font sizes, colors, and just everything. But at the same time, there are no constraints. Like you can configure like everything. You can configure the generated classes. You can configure like the values. It's just super flexible. And to me, I don't see myself writing CSS any other way. So now that we have a working blog that has support for interactive components, thanks to MDX, and the styling and taken care of using Tailwind, now it's time to add authentication. And for that, I'll be using Next.auth, which is an open source solution that just makes it super easy to add authentication to Next.js apps. There's support for many authentication providers, so you can log in with Google, GitHub, Facebook, Twitter, Discord. Most likely Next.auth has it or eventually will add it. You can also bring your own database, so you can have support for session-based authentication. And then finally, what's super cool is that there is support for passwordless authentication using magic links. So a user will enter their email, they'll be sent an email with a login link that they can use to access the platform. And this is exactly what I need. Now, to set up Next.auth, we're going to create an API endpoint that handles all of the authentication logic for us. So things like signing in, signing out, sending emails to users that contain login links so that they can log in, handling other authentication providers because we can have multiple ones. So to do that, in the pages/API folder, we'll have a new folder called auth. And in this folder, we'll have a file where we configure Next.auth. In this file, what I'm doing is first importing Next.auth from Next.auth, and then I'm doing a default export while calling Next.auth, and I'm passing in a configuration object. I'm then specifying a providers array. This is an array of authentication providers for signing in. So you can actually have multiple ones when you include them in this file. So you can have a GitHub provider, you'll import it and then include it. And you also need information like the client ID and the client secret. Now, for setting up passwordless authentication using email, Next.auth has two requirements. The first one is to use an email sending service so that we can actually send the emails that will contain the login links. And we need to have a database. Now, for the email sending service, you can use whatever service you want as long as it supports the SMTP protocol. This is the protocol used for sending emails. So for me, I'm using Twilio's SendGrid, and I just created an integration and specified that it's SMTP. And I grabbed the following information. So I got the host, the port, and then created a new password and just passed in the username. I also specified a from email. I used like my own personal email, but for example, you can use like noreply@yourdomain.com. Now, so far, authentication will actually not work because we haven't included a database yet. So we're going to do that first and then come back to this authentication portion. When it comes to working with databases, I've always been intimidated by them. I started out as a front-end developer, so this layer of the stack was just so abstract to me. Which database should I pick? what are the differences between each database? How do I actually work with these databases? And how can the design of my database evolve over time? I had so many questions and things were very confusing to me until I started using Prisma. Prisma is a next-gen ORM that makes it easy to work with databases. Now, if you're not familiar with what ORMs are, ORMs, object relational mappers, allow you to use a programming language to work with a database. This is instead of using the database's native querying language. Now, the added benefit is that you don't need to constantly context switch between two different languages when you're building your backend. So, for example, you're writing your business logic using JavaScript or TypeScript. You don't need to now I need to think in SQL, for example. You can just write more code. And this makes you more productive. Plus, since you're working with a programming language, the editor is on your side. So things like auto-completion, type safety, you can have just comments, and the overall developer experience when working with ORMs is better than just using the database's native querying language. Now, Prisma has support for different database providers. There's support for Postgres, MySQL, SQLite, Microsoft SQL Server, and there's MongoDB, which is in preview. Now, which database I'll pick, I'll go over that in a bit. But first, let's add Prisma to the project. The first thing you need to do is install the Prisma CLI as a development dependency. So to do that, just run npm install Prisma and --save -dev. And after that, you can use the Prisma init command, which will set up a basic Prisma project for you. So just run npx Prisma init, and in the root folder of your project, you'll find a newly created folder called Prisma with a schema.prisma file in it. This is where you define your data model and design the schema of your database. Now, this file is written using the Prisma schema language. So to actually get things like syntax highlighting, auto formatting, and auto completion, make sure that you install the Prisma extension for VS Code. Now, again, the reasons we need a database is A, to store the information for users who purchase the course, and since it's a requirement for having email authentication using NextAuth. Now, thankfully, NextAuth has an adapter for Prisma that makes it seamless to have session-based authentication and to just add support for logging in with email. The first thing we're doing is we're defining a user model. Now, a model in your schema.prisma file will be mapped to a table in your database. Now, we're going to have a table where we have all users, and each user will have the following fields. So a user will have unique ID of type string, and this will be randomly generated for us by Prisma. Each user will also have a name and email, both of type string. Both are optional. That's because we have this question mark. However, the email has to be unique. So we can't have two users in the database with the same email. Then we have an email verified field, which is used to determine when the user verified their email. There's also an image field, which is, again, a string of type string, and it's optional. And so this is so that the user can have a profile image. And then finally, we have a field called accounts, which is an array of type account. This references the model account. And then there's a field called sessions, which is an array of type session, which is also another model that we have down here. So what we're saying is a user can have many accounts and they can have many sessions. Now, the reason a user can have many accounts is because, say, for example, we added support for logging in with GitHub, logging in with Google, and logging in with Twitter. If a user uses each one of those authentication providers once, an account will be created for each one of them. And we want all of these accounts to be associated with one user. And NextAuth takes care of that. Now, the reason a user can have many sessions is, well, so that they can log in multiple times in the platform. For the database, I decided to go with PlanetScale. It is a serverless MySQL database that has built-in support for Prisma. Now, the fact that it's a serverless database means you won't run into the connection pooling problem. This is a problem you face when using serverless functions, like Next.js API routes, to access server-based databases. What happens is that each request opens a connection to the database. So during traffic spikes, you quickly exhaust the database's connection limit. This leads to failed requests and slow performance. Now, PlanetScale introduces a unique workflow when you're working with databases where you have different branches. So the way it works, you have your main production branch. And whenever you want to update this branch's database schema, you create a development branch apply the changes to this branch, and then you make a deploy request. This way, you actually have non-blocking schema migrations, and your database won't slow down during the migration process. Now, I went to PlanetScale, created an account, and created a new database. Then, in the database settings, I checked the automatically copy migration data and picked Prisma as my migration framework. After that, I promoted the main branch to production. Now, I'm going to use Prisma Migrate, which is part of the Prisma ORM, to actually create the tables in my database. And what's also cool about Prisma Migrate is that it keeps your Prisma schema and your database schema in sync. Locally, I'm going to use the PlanetScale CLI to create 2 development branches from the production branch. I'll do that using the pscale branch create command. I'll call the first branch initial setup and the second one shadow. The shadow branch is needed to make Prisma Migrate work properly. Then in 2 other terminals, I'm going to connect to these 2 database branches by using the pscale connect command. I'll also add 2 database connection strings to my .env file so that Prisma can connect to each one of those database branches. Now, PlanetScale doesn't support foreign key constraints, so we have to specify in our schema.prisma file that we don't want to generate any. So first, I set the provider to MySQL, and I also added a shadow database URL which will be loaded from my .env file. And then I enabled the referential integrity preview feature flag, and in the data source block, I added the referential integrity property and set it to Prisma. And now we can actually create our migration. So in a third terminal, run npx prisma migrate dev -- name to name our migration. And since this is the first one, I'll call it init. As you can see, a migrations folder has been created for us, and we can see the generated SQL. And now the next step is for us to create a deploy request. So to do that, we'll just run the pscale deploy request command. And if we go to PlanetScale and we refresh, we're going to see an open deploy request. So all we need to do is add changes to deploy queue and wait for it, and it will be deployed. So now I'm back in the file where we're configuring Next.auth, and I made a couple of changes. So the first thing I've done is I installed Prisma Client. Now Prisma Client, which is part of the Prisma ORM, is an auto-generated type-safe query builder. So that's what we'll actually use to send queries to the database. Now the next thing that I've done is I installed Next.auth's Prisma adapter. And in Next.auth's configuration object, all I did was just say adapter, Prisma adapter, and I created a new Prisma client instance by saying const prisma equals new Prisma client, and I passed it to the adapter. Now, the next thing that we want to do is actually check, okay, is the users that's trying to log in my database? If they are, then we'll send them an email with a login link. Otherwise, we won't send them anything. So to do that, we have a function called send verification request, and we can add our own logic here that sends a query to the database. And for that, we'll be using Prisma Client. Now, all I need to do is just say const user equals await Prisma dot, and if I hit Control space, I'll get autocompletion from VS Code. And what I see here is actually coming from my schema.prisma file. These are my models. So I can just say .user dot and hit Control space again, and I can see the different available functions that I can use. Now, these are functions for doing CRUD operations, so create, read, update, and delete. Now, what we want is to find a user by their email. So to do that, I'll use the find unique function. So now next to it, I can actually see how to use it. So what I need to have is an object with, and specify a filter by saying where, and then have an object. So let's do that. So I can just say find unique, do an object, hit Control space, and this says where, and if I hit Control space again, I can see that I can filter either by the ID or the email. That's because both of these fields are unique. Now I'm going to say email because this is coming from the front end, like from the identifier right here. And what I need to do is, okay, check if this query returns a user. If it doesn't, then we'll just return and not execute the logic that actually sends the email. So all I need to do is just say if not user, we will return. And that's it. We've added logic that checks, okay, did this user purchase the course or not? Now, the next step is for us to add support for payments. And whenever a user pays, they will be somehow added to the database so that when they try to log in, this logic will execute and they'll be able to access the protected content. Now, to be able to accept payments from users on my website, I'll be using Stripe, which is an online payment processor. Now, what's cool about Stripe is that it has developer-friendly APIs, but most importantly is that it gives you a hosted checkout experience out of the box. You don't need to mess with credit card validations, and it just saves you a ton of time. Now, to keep things simple, I'll only have one product. So I already am logged in, and I'm just going to go to my dashboard. And in the products tab, I can see that I already have a product. Now you can add a product where you specify all the details, like the price, and maybe even accept recurring payments. I'm just going to make it a simple $5. So now I'm on the landing page for my course. And when I click buy now, what happens is I send a post request to an API endpoint where we're creating a checkout session. Now, if I go back to my pages/API folder, I have a file called checkout.ts. And this is just straight from Stripe's docs. And we're defining a serverless function that creates a session for us. So what I have is the price, and this price comes from my dashboard. And yeah, we're creating a session, and we're specifying the payment method types and the mode and what happens on success and what happens when canceling. So for example, we can just say, okay, when the payment is successful, we can direct them to a page that says, yay, you bought the course. And we can create kind of an onboarding experience. And yeah, this is how simple it is. Now you're going to need the Stripe secret key, which also you can find in your dashboard. And that's it. Now, the final piece of the project is, in the event of a successful payment, we want Stripe to let us know the info of the user that just paid. So this way we can grab that info and save it to the database, and when the user tries to log in, they'll be able to log in and access the protected content. Now, this can be done through webhooks. Now, to configure webhooks, in your Stripe dashboard, there is a developers page, and on the left, we have a webhooks tab. Here, you can specify which type of events you want to receive and where Stripe should send them. Now, all you need to do is you click Add Endpoint, and you have one of two options. Either you specify the URL of your API endpoint, like the deployed version, or you can test in a local environment using the Stripe CLI, which is super nice. And now what you want to do is actually select the different events that you want to listen to. And for us, the ones that we're interested in is the charge succeeded. Now, I don't need to do all this stuff because in my app, I already created an API route and I called it webhook. This will be the endpoint. And I created a deployment to Vercel so that I can actually test this. And if I actually go to this endpoint right here, this is the hosted endpoint, I can see a log of different charges. So I can just see, okay, some of them failed, some of them succeeded, and I can click individual ones and I can find just all of this information. And for us, the most important info is the user's email, which we can find here. It's called officialcampo@gmail.com. So this is super nice. Now, there's one final thing. We want to secure our API/webhook endpoint. That's because anyone can just send us an event saying hey, I paid for this. So we want to make sure that the event is actually coming from Stripe. And this is done by including a signing secret in the request. And in the logic, which we'll look at right away, we will have a check that checks, okay, is the secret included in the post request that we're receiving? If it is, then this event is actually coming from Stripe. So now I'm in the /API/webhook file, and here's what we're doing. So I imported Stripe, and I also imported micro. This is going to be used for parsing the request because by default, Next.js does body parsing. So we are actually disabling body parsing by Next.js and doing it ourselves because it needs to be parsed a certain way. And then we're also importing Prisma. And we're creating a new Stripe instance by passing in the Stripe secret key, which is coming from our .env file. And we're also specifying the API version. And then we are just setting the webhook secret to the Stripe webhook secret, which also comes from our .env file. Now, in the handler function, the first thing we're doing is we're checking the request method. We want to only receive post requests. We don't want someone to just, send us a GET request. And what we're doing is we're saying buff equals await buffer request. So like this is so that we can parse the request, and then sig for signature equals request.headers and then the stripe signature. And what we're doing is we are actually constructing the event using 3 pieces of information. So the parse request, the signature, which is included in the like the request itself and the request headers, and we're also passing in the webhook secret. So this is now the event. And what we're doing is we're checking the type of the event and making sure that it's HR succeeded. And what we're going to do is actually write a Prisma client query to save the user to the database. So if I actually expand, what's happening is I'm grabbing the charge. So it's event from like event.data.object, and I'm just doing a Prisma client query. So I'm saying await prisma.user.upsert. So upsert, what it does is that it creates a new record in the database. And if there is an existing one, it won't throw an error because we can't have 2 users with the same email. And also, this way, we can accept payments multiple times from the same user, which is cool. So what we do is we're saying await prisma.user.upsert, and we're saying create. So if we don't have a record where the user with like the email that's coming from charge.billingdetails.email, we're going to create. But if the email already exists, we're going to just update the email. And if we have like other fields, we can also update them here. And where? Because we're finding by the email. So that's really it. And then I'm just saying res.status200.send, this works. So this is our course platform. And that's it. You just saw how to use a bunch of tools together to build a really cool project. Now, maybe you don't want to build your own course platform, and that's completely fine. To me, what's important is that you see the full picture and you can see how the different pieces fit together. Maybe you're a front-end developer and you've been curious about doing full stack development. Well, using Next.js plus API routes along with Prisma and PlanScale is a great choice. Or maybe it's the opposite. Maybe you're a back-end developer and you're looking for a great front-end framework. Using Next.js makes a lot of sense. Now, there's a reason that I picked these tools. All of them offer great developer experience, and at the same time, they have great developer communities. So if you have any questions, if you run into an issue, if you want to ask for help, you'll find someone to help you. And to me, that's just super important.
Hi everyone, I'm Kara Erickson and I'm a software engineer at Google working on the Chrome team. And I'm here today to talk to you about improving load performance with streaming. So you may be wondering, if I'm on the Chrome team, why am I here talking to you about Next.js? Well, specifically, I work on a project called Aurora. If you're not familiar with it, it's an initiative where Chrome engineers collaborate with open source framework and tooling authors to make the web better. On the Chrome team, we really care about user experience and a thriving web ecosystem. So one of our directives at Aurora is to help websites incorporate best practices for performance and accessibility and things like that to make sure that everyone has a great experience on the web. The thing about best practices, though, is that they're constantly evolving and changing, and it can be really hard for individuals to keep track of what the latest developments are. So this is where frameworks like Next.js really shine. Frameworks are in a really unique position to influence the web ecosystem. So if our team helps to bake best practices into frameworks, then the developers that use those frameworks can benefit from them for free. And they can focus on what really matters to them, which is shipping great products for users. So as part of Aurora, I've been working closely with the Next.js team to work on features that relate to our current focus, which is improving loading performance on the web. So one of these features is the topic of this talk, streaming, or specifically streaming with get server-side props. This feature is a project that I've been working on, but I wanted to point out that I'm not working on it alone. I've been working with Gerald Monaco, who's another Aurora team member, and who's been spearheading the streaming effort from the Chrome side. And of course, there's always feedback and support from the rest of the Aurora team as well. So I want to start by giving some context about our process. So all Aurora features go through a really thorough vetting process to ensure that we're actually improving the metrics in the way that we think we are. We start by identifying a problem, we research and prototype solutions, we validate them in production apps, and we move towards creating strong defaults for the feature in frameworks and tooling. So for this particular feature, streaming with get server-side props, we're pretty early in the process in the R&D stage. So far, we've identified a problem and we're working on prototypes. Given the early stage, you can think of this talk as more of a deep dive into the problem space and a sneak preview into early designs that aren't really solidified yet. For Next.js developers, hopefully it could be interesting to know what we're working on and what's coming up next. But even if you're not a Next.js developer, this problem that we're trying to solve is general to the web. So hopefully this can be helpful even to people using frameworks and libraries that aren't Next.js. So I'll take you through our thinking so far, starting with the first step, which is how we identified the problem. So what problem are we trying to solve? As I mentioned earlier, Aurora's current focus is to improve loading performance. So there's a couple of metrics that we look at to evaluate how sites are doing. One of these metrics is First Contentful Paint, or FCP. If you're not familiar, FCP measures the time from when the page starts loading to when any part of the page's content is rendered on the screen. So if you want a good FCP for your site, generally you want the first paint to occur in less than 1.8 seconds. Largest Contentful Paint, or LCP, is another metric that we look at. And if you're not familiar with this one, LCP is a metric that measures the render time of the largest image or text block on the viewport relative to when the page first started loading. So this is when the user has enough visual information to figure out whether the page is actually useful to them. If you want a good LCP, generally you want the largest paint to occur within 2.5 seconds. And anything that takes longer than 4 seconds is considered poor. And LCP is a little bit more of a signal that we use because it's a core web vital. So that's something that we'll be focusing on today. So let's take a step back. Why should you care about improving these numbers? So first, there's obviously UX considerations. It's not a great experience for users to be waiting around a long time for your page to load. But there's also business reasons. There's strong evidence that good web vitals can lead to stronger conversion rates and lower bounce rates, and users are just more likely to use your product. So there are several solid reasons to ensure your site has a good LCP. However, according to the 2020 Web Almanac, it's pretty common for websites to miss this LCP benchmark, especially on mobile. So if you look at this mobile graph on the bottom here, you can see that only 43% of sites have a good LCP, 35% need improvement, and a good 22% have actually poor performance. So this means that a majority of websites on mobile, 57%, are missing this benchmark. So this is a problem, and we want to improve this metric. So how can we improve LCP for any Next.js sites that fall into this 57% category? Well, to answer this question, we need to narrow down the problem a bit. So where do Next.js apps specifically run into trouble with LCP? In the general ecosystem, LCP is often degraded by issues with unoptimized images or script execution order, things like that. However, these issues are pretty well addressed in Next.js with components like the next image component, the next script component. So if you're already using these components, where else can you optimize your LCP? Well, it does depend on how you're building your Next.js app. Different app types lead to different LCP outcomes. So to review kind of the different data types that are available, there are a few common ways to manage data for your app. There is static site generation, or SSG. This means that you're using the getStaticProps function to fetch your data and pre-render your app at build time. There's server-side rendering, or SSR. This means you're using the getServerSideProps function to fetch your data and pre-render your app at request time. There's client-side rendering, or CSR. And with this pattern, you're rendering a minimal app shell on the server, and then you can fetch your data on the client side and re-render again on the client. There's also ISR, or incremental static regeneration, and this is where you build your site statically for some subset of pages, and then you render the rest of your pages on demand. So it's kind of a hybrid between two types. It can be a mix of static site generation or server-side rendering if your app chooses to fall back to SSR, or it can be a mix of static site generation and client-side rendering if your app falls back to an application shell and fetches data from the client. So let's go through these different data fetching types and show how they can lead to different LCP outcomes. So it may help to review in a little more detail how the page loads for each of these types. So let's start with an app using static site generation, or SSG. So let's imagine a request comes in for the website, right? So as soon as the browser connects, you start getting your first bytes of the HTML. So that's when you get to your TTFB, or time to first byte. And the HTML document starts to download and parse. Since this is a statically generated site, the full HTML page was pre-rendered when it was originally built. So at request time, we don't actually need to fetch any data or do any server-side rendering. We can just retrieve the fully pre-rendered HTML. So the HTML is downloading, the CSS style sheets linked in the head start to download and execute. And as soon as they're completely parsed, the screen will be painted, and we'll see both FCP and LCP fire a little bit later. Then the JS loads and executes, and React hydrates, at which point the page is fully interactive. So as you can see here, the LCP is already pretty optimized for SSG apps. Since the data is fetched and pre-rendered at build time, there's really not much to do at request time except serve the completed document. So if we're looking for places to optimize LCP, we can look elsewhere. So how about server-side rendered apps? So if we go through the same process here, we start with a request, and since SSR apps are rendered based on the request, we don't actually have the pre-rendered HTML ready to flush yet like we do with SSG. So we need to actually render the application on the server. But before we can render, we have to have all of our data ready. So generally the first thing that happens is that we make some API requests on the server. So for example, let's say there's two pieces of information we need, the user and some data about the user. Perhaps we make a call to the user API first to see, does the user have access to the page, or should we be showing like a 404 page or something like that? And once we know how we're going to route the page, perhaps we fetch some data from another API to actually get the content for the user. So at this point, we have all of our data available, so we can actually render the application on the server and generate the full HTML document. We start sending the HTML back, at which point, again, the CSS is discovered in the head and can start loading. at which point we can get to the first contentful paint and sometime later the largest contentful paint. The JS loads, hydration happens, and the page is interactive. Compared to the statically generated page, you can see that the LCP is a little bit later because we have to wait for all of the data to be fetched before anything is sent back. So nothing, the HTML, the CSS, or the JavaScript, can start to load on the browser side until all of those steps are complete. Okay, what about apps rendered on the client? So if you go through the same process once again, a user makes a request to the website, we connect, and since it's just a basic application shell, we can pretty quickly just start loading the basic skeleton with HTML and CSS. And so we get first contentful paint pretty early because we can start painting, like the header and like sidebar outline for the app or something like that. Then the JS loads, the app hydrates, and this is typically when the API calls for data, the actual content of the application might be kicked off. So again, we connect, we see the same calls to the user API and the data API, and whenever they come back, the app renders fully on the client side, pretty much. And this is when the largest contentful paint can finally occur, because this is when the actual biggest chunk of the content is rendered. So you can see that of all three, the client-side rendered apps are going to have the worst performing LCP because it takes so long for the API request to actually be set off in the first place. It's also worth noting that this would also be the performance signature of any like ISR apps that have that are client-side rendered. So if they have the static shell fallback, ultimately the LCP will act just like a client-side rendered app. So this is generally why we recommend doing the fallback blocking or the server-side rendered fallback, because it's slightly better LCP and acts more like a server-side rendered app than a client-side rendered app. Okay, so these drawings are not to scale, but if you look at the same three drawings, you can kind of get a general sense for how they compare. So you can see that for statically generated sites, you generally see the best LCP. So if you can build your site statically, you should. If you have to make API calls based on the specific server requests, then we generally recommend using server-side rendering because it's overall better on LCP, as the API calls are set off a whole lot sooner than for client-side rendering. So if we want to improve LCP for Next.js apps, server-side rendered apps are really the place to focus, and I'll tell you why. So with statically generated apps, there's really not a whole lot we can do to improve. The LCP for SSG apps is already really good. For client-side rendered apps, we already know how they can improve, right? So they can change their model to server-side rendered app and see big LCP gains, or if it's possible, they could move to static site generation. But really the question is, how do we improve LCP for server-side rendered apps? So if we look at the server-side rendered diagram again, the problem seems to be that we have to wait for all of these data requests to come back and for the whole app to render before any HTML at all is flushed to the client. So is there a way we can improve on that? Could we flush the HTML sooner? Maybe we can load the HTML and the CSS on the browser while we wait for the data requests to complete on the server. Well, this doesn't quite work because we don't have enough information to render the whole HTML document at that point in time. The data API hasn't come back, so we don't actually have the content, and we haven't done a full React render, so we don't have anything to show at this point. But what if we were to be a little bit more granular about which parts of the HTML we decided to flush? So instead of flushing the whole thing all at once, maybe we could flush smaller chunks over time. So you can see that this is starting to sound like streaming. And especially it sounds like the value proposition behind React 18 streaming and behind server components. And these are really exciting strategies that many of us are very much looking forward to using. But they are longer term solutions because React 18 isn't quite out yet. And some apps might not want to migrate to React 18 right away. Maybe they're a bigger app. So what can we do to help in the meantime? We were trying to think if there was a more limited type of streaming that we could do now with React 17. And this is where streaming with get server-side props comes in. This feature is a more limited type of streaming that we view as an incremental step towards the ultimate goal of adopting React 18 and server components. So rather than fleshing, n chunks like React 18, this streaming is limited to 2 chunks. So you can think of it more as a 2-flush pattern than true streaming. Regardless, the idea is that instead of gating the whole HTML document on all rendering, we can chop it up into 2 pieces and send each piece at the earliest point in time where we have the information to do so. So the question is, where should we split it up? So we have here kind of a mock Next.js HTML page. And you can see that in the head, we have everything that you might expect there. We have, title and meta tags, any preloads that we're adding, first-party CSS, fonts, and then the JavaScript for the framework and for any first-party code that the app developer has written. And then the body, obviously, we have some app content. So if we're trying to split it up, one way we might do it is like this. So in order to send headers and the head tag, we just have to know which page we're rendering. So we need to know what code to send. So for example, should we load the code for a 404 page or an error page, or should we load the code for like a real application page? So basically all we need is basic routing information, and then we can start loading things like first-party CSS and JavaScript. And this part of the document, the head and the headers, is not really contingent on data requests related to content, because as soon as you know like what page you're loading, like the JavaScript and the CSS is going to be the same. The body is really where we have to wait a little bit longer because we need all of the content to be available for it to be useful. So we can split it up into 2 flushes. So we have the first flush whenever the routing is complete, and we can just send the head, and the second flush whenever all of the data is ready. So if you look at it in the context of this graph, we have the first flush here after the user API that tells us whether the user exists resolves. And then we can have the second flush of the body when the full data API request is complete. So the benefit here is that the CSS and the JavaScript can start to load while this data API is still pending. So when it's done, we don't actually have to, load the CSS and the JavaScript after the HTML comes back. We've already done it, so we've saved ourselves some time. And we can also benefit from kind of a lack of resource contention because we've done a lot of work early. So if we compare the before and after, we can expect an improvement in LCP that really relates to how much CSS and JavaScript you're loading. Again, the drawings aren't to scale, so maybe this is a little bit hard to parse, but early tests show that making this small change can really help your LCP. So we worked with a partner for early testing of this idea in vanilla React, and they saw an improvement of anywhere from 2 to 5%, depending on how you measure it, in their LCP, which for them translated to hundreds of milliseconds. So in general, we expect to see improvements on the scale of about maybe 400 to 600 milliseconds on average. So how do you use this API? What would it look like to turn it on? Again, disclaimer, this is R&D, so this API will almost certainly change. But let's take a quick example. So let's say you have, you're using server-side rendering and you've implemented your get server-side props function like this. So currently, there's just one promise. So you'd start by grabbing your user from your user API, and then if the user doesn't exist, maybe you return a 404, and that's all you really need to know to figure out the routing. And then once you have your user, you get data for that user, and then you can return all of the actual content. So you can kind of see that all your API requests are grouped together, so the server has to wait for all of them to finish before trying to render the app. It returns one big promise for everything. So with the new strategy, we want to be able to send the headers and the head tag as soon as we know what we're routing. So we need to split this function in half to tell Next.js when it's safe to do this first flush. So we really need 2 promises instead of 1. One that resolves when the routing is done, so Next does the first flush, and the second when all the data is ready, so Next knows to render the app and flush again. So it could look something like this. So the first promise is kind of the same as what it was before. So it's the top level promise for get server-side props. This promise only waits for routing. So in this case, you get the user data, and at this point, it returns. But you can see that the props value returned is no longer just a simple object. Instead, it's an async function. So this is, once called, this will be the second promise. So essentially, next we'll call get server-side props and wait. And when it returns, we know that the routing is complete and it's safe to flush the headers and the head tag to start loading, everything in the head. Then next calls the function and the return value and waits for the results. And as soon as those are ready, the second flush can happen. So we're really excited about this idea, but of course, with any non-trivial feature, there are caveats that we're still thinking about that we wanted to share with you. So one is error handling. Since we send the status code with the headers before, as part of the first flush, if something goes wrong while the full application renders, or if one of the API requests that happens after fails, it's too late to send a 500 error because we've already sent, 200 or whatever it happens to be. And so in this case, that error handling would have to happen on the client. So there'd have to be some sort of client rendered error page. So that's not great. So that's something we're still thinking about. There's also some constraints with the response object. So typically in get server-side props, you can mutate the response and its headers anywhere in the get server-side props function. But now that it's split in two and part of the function is being sent at a different time, you have to be careful that you don't mutate the response headers after we've already sent them. And lastly, there are some constraints for users of next head and next script. And for those that aren't familiar, so we'll use next head as an example. So basically what this means is that it's kind of a shorthand. So if you add next head anywhere in the component tree, it'll take all of the tags inside of it and just stick it in the head, like the actual head of the document. And the before interactive strategy for script is something similar. So the reason that this works in the current way that the page loads is because we render the whole application first, and then we flush the whole document, which includes the head. So during this rendering process, we'll go through the whole application tree and discover all of these head instances that, so we know all the tags that we want to put in the head before we flush the head. But if we change the order like we're proposing here, then it doesn't work quite as well because we flush the head and then much later, or depending on how long your API is, at some point later, you server-side render and then you will discover all of the head usages afterwards. So it'll be too late at that point. So that's something that we need to manage. So one way to do that would be to split the server-side rendering in two as well. So we could render just the top level app component before the head is flushed. And then later, when we have all of our data available, we can do the full server-side render of the whole tree. And then at that point, we can flush the body. So this is a new constraint for next head and next script, that it has to be in the app component specifically. However, this is the same constraint that you will have anyway if you want to eventually upgrade to React 18 streaming or server components. So by adopting this strategy, you'd still be reducing your upgrade burden ahead of time. So this type of streaming is helpful for apps that don't want to migrate to React 18 right away, but also it's a good incremental step for any apps that do plan to make the move in smaller pieces. So if you're going to move your head and script to app, it might look something like this. So this is your top level app component. You put, whatever you want to put in the head at the very top. And then you can have a conditional render here where if your data is loaded, so in this case page props, then you render the full tree. And if your data isn't loaded, you return null, which kind of skips the rendering of the rest of the tree. So that the first render is really cheap. And so if you look at this code, it's really similar to what you will probably want to do once you start using suspense, because you want your head tags to be above the top level suspense boundary for the same reason. So as you're migrating, this would be a pretty quick transition. So how do you get this feature? What are the next steps? Well, as previously mentioned, we're still in R&D, so there's a fair amount of work and validation that we need to do. So keep your eyes peeled for announcements, but we do have an RFC, so please leave feedback and comments and let us know what you think. Thank you.
Today, we'd like to show you the future of collaboration with Next.js. At Vercel, we've learned a lot about collaboration from creating Next.js and helping companies of all sizes build a better web. Modern front-end teams want to share and receive feedback instantly. Their workflow is rooted in active collaboration. These teams are continuously iterating and need tools that reduce friction. We set out to reimagine how front-end developers work together. What would a highly active, visual, and collaborative workflow look like? To answer this question, we started by focusing on iteration speed. Forget manually setting up deployment pipelines or provisioning servers. Git push and instantly get a preview deployment with your changes. Share these live URLs with your team for feedback and collaboration. When you're ready, deploy immediately at every edge with production-ready infrastructure. This was a great start, but we want to take collaboration even further. We found two areas for improvement. First, while developers are used to setting up local environments, it's painful to install, download, and configure tooling when it could be as easy as opening a document in your browser. Both beginner developers and those new to your company struggle with this. Second, it's hard for reviewers and developers to get on the same page. Today, collaboration is often unnecessarily asynchronous. We envision a world where it's faster to make a change to the front end than chatting about it on Slack. Coding should feel more like editing a document together. At our last event, we gave you a sneak peek of Next.js Live, allowing you to instantly share, chat, annotate, and edit code from anywhere in the world. Next.js Live enables real-time collaboration for your entire team. I'm excited to share further improvements to Next.js Live, including faster performance, branch synchronization, and Git integration. Next.js Live makes development, ideation, and design happen in the browser in real time. Rather than waiting on a build process, you can instantly open a live URL for your entire team to collaborate on. When Monogram wanted to collaborate more quickly with their clients, they joined the Next.js Live private beta. Monogram is an agency that builds incredible sites with Next.js on Vercel. One of their clients is Mac Stadium, one of the largest cloud providers for Mac hardware. Both the Monogram and Mac Stadium teams have worked with us to improve Next.js Live and shape the future of collaboration. We've made it even easier to open Next.js Live from any website or branch you're working on. I can add _live to the URL, which maps to my Git branch. After I securely authenticate, I'm in, without any installations or extensions. You'll notice my live toolbar at the bottom of the page. This enables me to chat, annotate, and most importantly, edit any content. Let's have Belle join to review this page and give me feedback on the design. There she is. As you can see, her avatar appeared in the toolbar and her cursor position updates in real time. Looks like she's commented that we should change the CTA to get started now. Let's try making these changes live and see her instant reaction. Looks like she likes these changes. Awesome, let's ship it. If I click the commit button in the top right of the editor, I can instantly commit my changes to the current branch on GitHub. I'll pass it over to Belle, who will tell us more about how we take code to production with confidence.
Inside GitHub, you'll notice that Vercel GitHub integration automatically recognizes that I pushed a commit and creates a preview deployment. This immutable URL is a snapshot in time. This is different from Next.js Live, where multiple updates can be made to the same URL. So how do we know that this change proposed will have a positive or negative impact on our site? Google, in conjunction with the Web Performance Working Group, has established a set of metrics to accurately measure how users experience the performance on your site. These metrics are called core web vitals and track perceived loading speed, responsiveness, and visual stability. All three essential for your website's overall health. Instead of making changes based on intuition, we want to know before merging and going to production that our core web vitals are healthy. With Vercel checks, we can run automated tests for performance and reliability on every pull request. Vercel checks are deeply integrated into your existing deployment workflow. Teams can configure their projects to block merging unless specific performance budgets or tests pass. To demonstrate this, let's add the Checkly integration into our project. Inside the integrations marketplace, let's find the Checkly integration. Then we can grant the integration access to our project. Let's add the integration to all our projects on our team. Our Checkly integration opens on a new window. Finally, we select the projects we want to set up automatic checks for. And that's it. We can now start pushing commits. These automated performance checks are monitoring core web vitals like largest contentful pane, which measures loading performance, total blocking time, which measures interactivity, and cumulative layer shift, which measures visual stability. We want to aim for healthy core web vitals shown by green values. Our check will fail if performance has decreased compared to our last production deployment. For example, dropping from green to orange or from orange to red. Let's try it out. Let's push another commit to the branch we started. Looking at the deployment on Vercel, our automated performance checks started automatically and reported the results when finished. These checks are testing the actual preview deployment. If our application was not functioning for any reason, including runtime errors, our checks will fail. Great, our checks passed and we're good to merge. We've designed these checks for partners like Checkly, Cypress, Calibre, and more. But not only for performance, databases like PlanetScale, Fauna, Supabase, and Xara will soon be able to create branch-specific versions of your database with Vercel Checks API. We're working closely with our customers to define the future of Next.js Live. We can't wait to make real-time collaboration available to everyone. Go to vercel.com/live to join our private beta, and go to vercel.com/checks and add checks into your workflow to deploy with more confidence.
Hi, I'm Tim, CTO and founder at Checkly. Checkly is used by the best dev teams to ensure the reliability and performance of their web apps and APIs. Let me show you how you can monitor your next app with Checkly. First, you use our powerful JavaScript-based browser checks to make sure your web apps work reliably and fast. We automatically give you web vitals, console logs, network data, and a lot more. Then you add some API checks to make sure your backend APIs are snappy and respond with the correct payload. Of course, if anything fails, we will alert you on Slack, email, SMS, and a whole bunch of other channels. Lastly, you hook this up to your Vercel account with our new deep integration so you never ship any broken web apps again. Sign up for a free developer plan over at checklyhq.com.
Your app just crashed. The phone running it has exploded. It was struck by a hammer manufactured in 2005 by Harry's Hammers. The hammer's head is composed of 75% nickel, 20% steel, and 5% iron. The phone flew into the air at an 86-degree angle and came crashing down at 11 miles per hour.
Hi everyone, I'm Segun Adebayo. I'm the lead maintainer and creator of Chakra UI. And in this talk, I'm going to show you how to build an accessible slider component with state machines and state chart. My hope is I'm able to explain these concepts in a way that's approachable and easy for you to understand. Let's dive in. A slider component, just like we know, is basically a custom version of the input type equals range. In this talk, we're going to focus on 4 key areas. First one is to make sure the slider component works with pointer interactions, like the mouse or the stylus. The second one is to make sure that the slider component works with keyboard inputs like the arrow left, arrow right, home key, end key, that just changes the value as you press the keyboard. And the third one is to make sure we attach the proper area attributes to the component. And if we have some time, I can go through how to add labels to the slider component and to make sure the slider works within forms. Before we go ahead to talk about the slider, it's always a good idea to understand the different parts of a slider component just to help with terminologies and also help you understand which part I'm referring to. The first part I'm going to talk about is the slider track. This track represents the full range of the value from its min to its max value. And the thumb represents the current state or the current value of the slider, and it also serves as the control to scrub or change the value of the slider component. The range is basically a visual indicator that shows you what the value is at any point in time relative to the full length, which is the maximum value. With state machines and state charts, it's really important to understand the different states the component could be in, so it's really easy to model the logic or draw a very visual flow chart to see the different state and how you transition between them. The slider component has three different states. It has the idle state, which means no interaction is happening and the slider component is basically idle. We have the focus state, which means when you press the tab key to control or set focus on the slider component, that's basically what we refer to as the focus state. And the dragging state, which just means when you put your pointer anywhere along the slider track and you just scrub the value through by moving your mouse or moving your pointer to change the values rapidly. That is the dragging state. And I mention these states because it's going to be a very interesting anchor around all the entire talk I'm going to give in today. So we're going to look at the state charts and how you can send events within the state machine and what events you can send. The first one is when we're in the idle state, we can pointer down, which means hold anywhere along the slider track. Just put the pointer down there, and what we're going to do, as we know with input type equals range, is going to set the value of the slider to match that point where you sort of put your mouse down. And the second one is the focus, which means I can press the tab key to set focus on the tab. These are the two events you can send when the slider is in the idle state. When the slider is in the focus state, which means either when you use your tab key, you can send a couple of events, and one of them is you can perform arrow left or arrow right, which allows you to increment or decrement the value depending on what is pressed. You can also press the home and end keys to set the value to the minimum value or to set the value to the maximum value. Another interesting thing you could do is to blur, which means because the slider thumb has focus, you can click anywhere outside the page to blur, or basically we call it click outside the component to reset it back to the idle state. Or you could also pointer down, which means you could put your pointer down on any point along the track and just start dragging, which takes the slider into the dragging state. In the dragging state, you can scrub along the track just to change the values rapidly to the left or to the right, which increments or decrements the value. Or you can pointer up, which means you release your pointer and you're done with the dragging session, and that takes the machine back to the focus state. Now, all of the different things I've showed you right now can be represented in a flowchart or basically a state chart so you can understand the different states and the transitions between them. So the states are represented with boxes. We have the idle state, the focus state, and the dragging state. And the transitions between them are modeled with arrows. Here you can see the yellow arrows that indicates the blur, the tab, and all the different events we could send. Within a state chart, when you transition between states, you're able to modify an object called context. This context is an extended piece of information that is very specific to the machine itself that you can change along as you change between states. For a slider component, you'd expect that it has minimum value, maximum value, whether the slider component is disabled or not, and other possible things that would be helpful to change the behavior of the slider component. And here, as described, you see that we are going to assume that the slider component starts with the idle state. That's what I'm showing with the asterisk initial right there. To model this logic or this flowchart I've shown you so far, I'm going to be using the xstate library. I think Exit is an awesome library, and it helps me use the object representation to describe the different state the machine could be in and the transitions between them. The create machine function that you see in here is a function from Exit itself, and that just helps me define the ID of that machine, which is slider component, the context object, which would include the minimum value, the maximum value, the current value of the slider, whether the slider is disabled, and other values that I could use within the context to change the machine's behavior. As we described earlier, as we saw in the previous diagram, the initial state is idle, and then we can also define the different states the machine could be in and the events that could be sent. Just to help you get a quick idea, we have 3 different states as we saw: idle, focus, and dragging. Exit has a notion of a nested on key, which is used to describe all of the different events that can be sent to the machine and how the machine should interact or respond to these events. And in different states as well, in each state, you're able to specify a key called entry and exit, which helps you to define the actions that are going to be run when you enter a specific state or when you leave a specific state. The last one I'm going to show you is called invoke. Invoke is pretty interesting because what it does is to help you to define, within the context of this talk, it's going to help you define event listeners or long-running activities that your machine needs to listen to while it's in that state. For the purpose of this talk, we're going to be using invoke to define or to listen to the pointer move event when it's in a dragging state. As I showed you in the diagram, we're going to try to see what the object representation of this logic looks like. In the idle state, as we saw earlier, you could send a pointer down event, which means the user puts the pointer down on any point along the slider. And what we are trying to see with this object that says target is we want to send the machine to the dragging state. And the actions we want to run when that happens is we want to set the value for that point. Basically, it means wherever the pointer is and I put my mouse down there, set the value of the pointer to be that point's value, which is what we're going to implement later on. And the other thing we want to use is when you hit the tab key, which sends the focus event, we want to say send the slider to the focus state, basically. In the focus state, we can also see something interesting is happening here. On entry, we say when we enter into the focus state, we want to make sure the thumb has focus. So basically, the thumb usually would have a tab index of 0, and we just want to call the focus method to make sure that it always retains focus when it's in the focus state. And then the events we're going to send to this machine are pointer down, which means I put my pointer anywhere along the track again, and I'm going to set the value for that pointing event, which is the actions I'm going to run there. And I could also send a series of events for the keyboard navigation, which is pointer left, pointer right, home and end keys. And that would basically increment the value, decrement the value, or set the value to min in event of home, or set the value to max in event of end. I can also decide to click outside, which is basically because this slider has focus, I can click anywhere outside the page to indicate that I'm done interacting with the slider. And that is basically what I refer to as the click outside or the blur event handler. In this case, we tell the machine to go to the idle target, which means go to the idle state. In the dragging state, we see that we can, because we already pointed down along the track and we sort of scrub along the mouse with the mouse or with the pointer, we're just going to call this function called focus thumb, which is basically to ensure that the slider thumb has focus all through as you scrub through the slider. And we invoke a listener called track pointer move, which is going to help us attach listeners to the body of the document and make sure we actually set the value as you scrub through in there. And that's why we have the set value event within the on key. And while I'm dragging, you can definitely send an event called pointer up, which just indicates that you're done scrubbing and you want to go back to the focus state. Now we've seen all the different ways to describe the interactions and the states within a slider component. And then the next thing comes, how do we take this logic and this piece of state and bind that to the DOM? And what I mean by the DOM is, how do we define the attributes? How do we define the events? How do we define the area attributes and properties that should go onto these elements? All the different parts of the slider component. To solve this problem, we have to do 2 things. The first one is to consume the slider machine. So here we have an import use machine from exit React. This is a hook, a React binding that helps us consume the slider state machine within the React framework. When we invoke this function or this hook, it gives us access to the state and the send. The state is the current representation of the slider machine, and it includes a couple of utilities, and especially it tells us what state the machine is and what the context value is at that point in time. The send function basically works like the dispatch when you're using a reducer and use reducer hook in React. It just helps you send signals or send or dispatch events to the machine. Remember earlier on we looked at the on key and all of the different events. So the send function just helps you literally dispatch this event to the machine. On the right side, we are able to connect the machine to the DOM itself. So what it says is it takes the output from use machine hook next state, the state and the send, and is able to return back to me very useful information I could use when I want to render my UI. So here in this example, we're checking if the state matches focus, which means if the machine is in the focus state, we're assigning that to its focus property. And if the machine is in the dragging state, we're assigning that to its dragging. But these are very useful booleans you could use to conditionally render any element or just manipulate the UI the way that's designed. And one more thing you can see here is prop getters, basically, or properties that sort of a bunch of properties that translates to DOM attributes. Here you can see the thumb props. The thumb props basically returns all of the properties you need to spread onto the thumb element to make sure that it's properly accessible and it works correctly with the keyboard and pointer as described in the Y-area specification. So you can see here we give the role equals slider, we append area disabled, which sort of equal to the context that is disabled, and we have area label, we have value max, value min, value now, the tab index property, and all of the different properties to make sure that the slider component works correctly in the context of React. And because this is a pure function, this can be used anywhere else, not just in React, which is what I'm pretty excited about. We've looked at all of the different ways to get the logic of the slider component into the page and translate that to DOM attributes. We're going to go over the steps again to review the entire step. The first one is to import the slider machine and grab the use machine hook from exit React. That is going to give us access to the current state of the machine and the send function which we use to dispatch events. Next, we're going to translate the state and the send that comes from the xstate machine to DOM attributes and very useful state properties that we can use to render our UI. So in this example, you see we have the track props, the range props, the thumb props, and if you have to use it in the form, we also want to return the input props. 3, we want to render the UI. So which means I want to render the HTML structure to make sure that it's very semantic and is well structured to make sure the styles work correctly. And here I've given everything a class name just to show you how we can style this and make sure that it's very consistent and looks like a slider element. And you can see that based on the previous slide, I showed you we can translate the state and send from the slider to get properties. And here when I render the component, I just spread the attributes onto the element. This makes me clearly separate the logic of the component from the rendering of the component and the styling of the component, which is a great way to model UI components. I'm going to show you a demo of what this looks like in Code Sandbox. Here in Code Sandbox, we have the slider component set up, and I've also tried to visualize the state of the machine here in this pretty JSON object. In JSON object, it shows you the value key, which represents the current state of the machine. It shows the context, which is basically all of the different extended state information that I want to change as I transition between states. The next one is the event, which I think you can keep an eye on because it just represents the events that have been sent to the machine using the send function. And the next events key just shows you what events the machine could respond to. Because this is built using a state machine, we can ensure and we can make sure that the machine only responds to specific events. This makes it very easy to understand the flow and the logic of a component and even debug the component or test the component. So to start, I'm gonna start with the pointer events, which means I'm gonna take my mouse towards the slider track, Click anywhere along the slider track and sort of drag the values. Now, while I do this, you can see that the machine is currently in the dragging state. The context value changes as I drag along because I'm setting the values correctly. And you can see the event being sent is called setValue, which is what is sent from the invoke definition I showed earlier. And the next event the machine can listen to is the pointer up event. So I'm going to release my mouse now to just get out of this state. And when that is done, you see that the machine is now in the focus state, and the event that I sent earlier was pointer up, and I can now send a couple of events to the machine. Let's check the keyboard events. So I'm going to use the arrow left and arrow right to change the values, and you can see that the value changes based on direction or all the arrows that I press. The next thing I can do is to use the home and the end keys, as you can see there, to set the value to the minimum or the maximum value of the slider. And I can hold the shift key with arrow left as well to increment the value at much greater steps, in this case 10 times the step defined in the context. That makes it easy to just get through the value and scrub through or pick a specific value within range a lot faster. Now, these are the different ideas or different concepts within a state machine, and I hope this is very useful and you find it very valuable to learn about how to build accessible components with state machines. The thing I'm most excited about is the fact that you can take these machines and use them not just in React, but in Vue, in Svelte, and even in Solid.js. I'm really excited about this idea, and I'm really excited about the future of building accessible components. Thank you so much for watching my talk, and if you have any questions, feel free to reach out to me on Twitter, send me an email, or check my GitHub account as well. Have a great Next.js conference. I'm so excited to be here.
Hey everyone, I'm Lee, the head of developer relations for Next.js and Vercel. And today I want to show you how Next.js is helping create the developer experience of the future. Our team is focused on enabling developers to create a better experience for end users. Every design decision we make is rooted in three main goals. 1, building the SDK of the web. 2, lowering the barrier of entry. And 3, focusing on the end user. We've worked to provide tools and optimizations inside Next.js that make performance improvements an NPM update away. For example, improved performance with image, font, and script optimizations, faster builds with Webpack 5, and smaller file sizes with route-based code splitting, lazy loading of components, and more. Today, I'm excited to share even more improvements to the developer experience of Next.js and ultimately the end user experience. There are two separate environments for optimization inside Next.js, local and production, each with their own goals and requirements. Your local environment should be lightweight. It should get out of your way and enable you to build your product faster. It should defer non-critical work to the background. Your production environment should be optimized. It should use native infrastructure and offload work to the browser. It should be safe, reliable, and build quickly. We want to help bring development teams into the future, which is why Next.js now supports ES modules built in. ES modules bring an official standardized module system to JavaScript. They're supported by all major browsers as well as Node.js. This standard pushes the web ecosystem forward by enabling smaller package sizes and ultimately a better end user experience. As the JavaScript ecosystem transitions from CommonJS to ES modules, we're committed to helping developers incrementally adopt these improvements without unnecessary breaking changes. When we released Next.js in 2016, it was built on top of Webpack and Babel. Now, this solved two major problems for developers. 1, developers wanted to bundle multiple JavaScript files into one, and 2, developers wanted to write modern JavaScript while still supporting older browsers. But setting up these tools on your own was difficult. Next.js made it easy to compile and bundle your code with zero configuration. Over the past 5 years, we've worked to optimize the performance of our JavaScript toolchain while maintaining extensibility and backward compatibility. Today, we're bringing Next.js to the future with a brand new Rust compiler that takes advantage of native infrastructure. Our Rust compiler is built with SWC, an open platform for the next generation of fast tooling. The Rust compiler touches your code as little as possible and offloads work to native browser features. We're joining companies like AWS and Cloudflare who are investing in the future of Rust. This compiler has allowed us to optimize bundling and compiling even further, with 3 times faster refresh locally and 5 times faster builds for production. Let's take a look at a demo of the new Rust compiler for Next.js and see how it improves both your local and production environments. We'll be using the repository for Vercel.com, a massive Next.js application with thousands of pages and components. On the left, we have a version running Next.js 10.2, which was released about 5 months ago. On the right, we have a version running Next.js 12 using the brand new Rust compiler. Let's run next build to compile and bundle our code for production and compare the results. As you can see, the right side finished in about 2 minutes. Let's fast forward the build on the left. Okay, now it's done. With our new Rust compiler and performance improvements, we were able to reduce the build time for Vercel.com by almost 50%. These improvements to my production environment help me ship code faster. Next, let's talk about improvements to our local environment. Let's make some changes to the analytics page locally using the version of our codebase running Next.js 12. Let's change the button text to say Next.js 12, and if we look at our terminal output in the bottom left, after saving, the output of each fast refresh is shown in the console. You'll notice that edits appear almost instantly around 100 milliseconds. That saves me a ton of time. The new Rust compiler already supports compilation for all new Next.js features, including Style.jsx and popular community libraries like Tailwind CSS, which relies on PostCSS. And if you have a custom Babel configuration, your existing applications won't have breaking changes and will continue to work. There's one more thing. Next.js now has experimental support for URL imports. URL imports allow you to use any package directly through a URL. No installation or build step required. Any CDN that serves ES modules will work, as well as low-code and design tools of the future. Let's take a look at a demo using Framer. To demonstrate URL imports, let's look at Framer on the right and our new card component, complete with hover states, assets, and more. Now, normally you'd have to work between designers and developers to translate this design into code. Instead, let's use this card component directly in our Next.js application. If we click Handshake on the right, we can see the URL import for this component. Let's click Copy, go back to our browser, and on the left, inside of our code, let's import that component. Then we can use this card inside of our JSX, and if we hit save, we'll see it show up immediately in the browser, complete with hover states. Now, URL imports are just React components, which means that we can use variants inside of Framer to change the variation of the card we're showing through React props. With our new Rust compiler, we're creating the foundations for fast development tools all across the board, on your machine, your CI, and in the browser. The best part, most of these improvements require no changes on your side. The new Rust compiler is built with incremental adoption in mind and is backwards compatible. With ES module support, Next.js can ship smaller JavaScript bundles to users, and your developer experience gets even better with the introduction of URL imports, enabling seamless integrations with no-code and design tools like Framer. Upgrade to Next.js 12 today and try out the developer experience of the future.
Prisma, we redefine the developer experience of working with databases with a next-gen ORM. You write your data model in a human-readable schema, allowing anyone to quickly understand how your database is designed. You then get an auto-generated, type-safe query builder that you can use to read and write data to your database. And when your schema needs to evolve, you run a single command that auto-generates migrations for you. However, regardless of whether you use Prisma as your ORM, working with traditional server-based databases in a serverless environment, you run into an issue. Each serverless function opens a connection to the database, so during traffic spikes, you'll quickly exhaust the database's connection limit. This negatively impacts performance and leads to failed requests. That's why we've built the Prisma Data Proxy. It's a service that sits between your server and database and handles database connection management for you. It's currently in early access, and we would love for you to try it out. To learn more, go to pris.ly/dataproxy.
Hello and welcome. Today we are going to be talking about 5 things you must know to take your next app to the next level. My name is Ankita Kulkarni, and I'm a Senior Engineering Manager at Vercel. I am part of the growth org at Vercel, and it has been a fun journey so far. I've been working in the industry for the past 10 years and built all types of applications, all the way from greenfield to production, and also taken a lot of existing applications to production and scale them as well. Today, my topic is 5 things to take your next app to the next level. So, what are we waiting for? Let's get started. So, when it comes to taking your apps to the next level, there are a few important things that come to mind. One is performance, optimizations that we can make along the way, caching data on CDNs, and so on, right? There are a few things. Today, we are going to be talking about a few things that I think will help take your app to the next level. 1, SEO. 2nd, loading and redirect. 3rd, incremental static regeneration. Then image optimization, and lastly, caching. So let's get started. SEO with Next.js. SEO stands for Search Engine Optimization. Let's talk about what exactly is SEO first. When your app gets deployed, your bot goes ahead and crawls the page. The minute it crawls the page, it is then going to understand what's on the page. Once it understands what's on the page, it is then going to go ahead and rank your page. Now, just like you and I, we are communicating in English, Mr. Bot is going to go ahead and take a look at your HTML to understand what's on your page. So it's extremely important to set up your meta tags, titles, use proper HTML semantics, and so on. There are a lot of things about SEO. It is then going to go ahead and display on the page. Now, it's extremely important that you get your SEO right, because that is how you're going to get a lot of users. The minute users are going to search for a specific search term, you want your specific site to go ahead and pop up right there on the first page. So SEO is important. Now, what I really love about Next.js is that it really makes it easy for developers and gives developers such a good developer experience when it comes to implementing SEO. A lot of the things are done out of the box, but a few things that we can add on to is the Next.js head component. But first, let's take a look at a demo, and then we can go from there. So this is an app called Meow Props. As we know, on Twitter, there's a lot of debate, a lot of heated arguments going on Twitter. I built this app to essentially give props to someone you really like, someone you really appreciate. Now, in this specific app, you can go ahead and add your Twitter ID and their Twitter ID, and then accordingly, it's going to generate a unique link for you that you can share with them and tweet about it. That it's also going to go ahead and randomly assign a compliment to that specific tweet as well. And all this is built with Next.js using the power of incremental static regeneration. And we will take a look at soon in that specific section. But for now, let's focus on SEO. So now for Meow Props, as we see right here, we have 2 input boxes. So let's go ahead and add our Twitter ID and their Twitter ID. So their Twitter ID could just be another awesome person, and our Twitter ID is my Twitter ID, which is Kulkarni Ankita 9. And here it has gone ahead and generated this unique link with some random number. Now we can go ahead and preview the page. The minute we do that, you can see how there is a meow emoji, right? But also a random compliment that has been picked from my JSON list of compliments. And it says, "You're awesome." Now, this specific content and this specific page is generated using incremental static regeneration. Now, isn't that amazing? So here it has gone ahead and opened up my Twitter and then accordingly gone ahead and shown the unique link generated for me. Now, I can copy this link and head over to Card Validator. Card Validator is provided via Twitter, a tool that will help you essentially identify the SEO for your specific URL, right? How exactly will it look like the minute you share the specific link? So let's paste the URL that we just copied and preview card. And now you can see this is exactly how users will see. Now, isn't that amazing? It has gone ahead and picked up the meow emoji from our page right here. And also the description is, "Thank you for being an awesome person." Isn't that exciting? So now let's take a look at the code and understand exactly how we would build this and configure this. Here we can basically look at some of the code. So now this is the head component and these are all the meta tags that are responsible for setting the title, the description, and so on. Now you can also go ahead and set the image as well. And next, these are all the meta tags specifically for Twitter. And if you use these specific meta tags for Twitter, you're definitely going to get extra bonus points because Twitter recognizes these cards. So the card validator looks at these specific cards to understand exactly how it will configure your specific URL and how it's going to go ahead and share it with other users. So you can see Twitter description, Twitter image, creator, card, title, and so on. So that's the beauty of Next.js, that we can easily just use the head component and pass in the meta tags and it is going to go ahead and append to the head of the page. Now, isn't that amazing? The next thing is script optimization. Now, script optimization is definitely one of my favorites feature of Next.js. Script optimization essentially allows you to optimize your script. So for example, if there is a specific JavaScript file or any specific scripts that you want to essentially load on the page, you can use the script component from Next.js. And using that component, you can pass in properties such as before interactive, after interactive, and so on. Before interactive would essentially give it a higher priority and load it before the page loads, right? But after interactive would be after the page has completely rendered, it is going to go ahead and load the specific script. Now, in our case, by default, it's after interactive. So after the page has fully loaded, it has gone and rendered the script. Now, in our example right here, if we don't use a script component, this specific widget is not going to work at all. So that specific script is extremely important. But using the script component, it has essentially figured out how to best optimize it and provided us with additional abilities like that. So SEO with Next.js is really fun and you can do a lot more stuff with it. Loading and redirects. Let's take a look at an example for what I mean by that. Let's say we have a login page and a home page. On success of login, we want the user to be redirected to the home page and also show some loading state in the middle. And let's say there's an error, then we want the user to stay on the login page and then show an error right here. Now, login has some async handle login request function that we trigger, right? And then accordingly, we use the router, the Next.js router, to push the user to either home page or stay on the login page itself. Now, what exactly happens here is when we click on login, that's when we execute the code and accordingly can redirect. It's pretty straightforward in that sense because we know exactly what we want to do here. But let's say now the user is already logged in, right? And they go away and they come back after 10 days or so. And then the minute they do that, they directly go to the home page, and all the content on the home page is server-side rendered itself, and then you see fancy image right here. So the minute they come to the home page directly, what we want is we still want this loading text, and we don't even want to show the user fancy image at all if in case the user is not logged in. If in case the user is not logged in or the session has expired and so on. But let's take a look at an example for what actually happens then. So this is a Netflix application, and you can see that the minute we go to the home page, loading text, Flickr, login page, right? And this is exactly what we want to avoid in a lot of applications. So let's take a look at what's the difference in Next.js here, and how is React getting rendered, and how the server-side rendering content works. So this is an example of the code that was the initial Flickr example, right? This is a code example for that. So now right here we have the router, and based on if the user is logged in or not, we redirect them to home or the login page. And in return, we are also returning the component as well. And all this is underscore app.js file, which is the entry point of our application. Now, what happens is, just because React has not even been initialized here, it has to still load on the client before the code can be evaluated even. So it's just better to use JavaScript in that case, right? So anytime there's an async call, this might happen. And then we go ahead and return the component itself. And component itself comes from my app. So this is going to be every page in the application, right? So just because React has still to load on the client, what essentially happens is this specific code is not even evaluated yet. And because of that, at the bottom, the component gets returned, which is our home page in that case, as the user goes to the root page itself. So how can we fix this? What is a good solution for that? Well, one potential solution is to use the Next.js router and subscribe to routing events. So that is, the minute the route change is complete, we turn the loading to false, but by default, show the loading component the minute the user routes, right? And this code works for sure, but it is not an ideal solution. Because why use the router for checking for the loading state and all that, right? It seems a bit odd. So the next solution could be to essentially using a script tag and then adding the document.cookie value itself, right? That is, we add a cookie inside our cookies in the application and then accordingly redirect to home if the cookie exists. So setting the cookie accordingly and then redirecting to home. So this is one potential option that we could explore. Next, let's talk about incremental static regeneration. Now, I have seen and talked to a lot of developers who know about static generation. They know about server-side rendering. But incremental static regeneration is known by a very few. And it's incredibly powerful. I've used it quite a bit and it has really blown my mind away. It's amazing. It's the best of both worlds. You don't just get the benefit of static side generation, but you also get the benefit of server-side rendering. You essentially would be able to pre-build content, right, during the build phase before deployment. It will go ahead and essentially cache all this different static content, right? At the same time, you can also dynamically render server-side render code as well. Now, the meow props that we looked at, that uses incremental static regeneration because of how much I love it as well. So, what makes incremental static regeneration powerful? Let's take a look at the code. So now this is the example code from meow props app itself. So we have two functions here. One is get static props, other is get static paths. So towards the bottom, we are caching that specific value, that is the static content for those two Twitter IDs, right? And on top for get static props is when we are essentially server-side rendering the code as well. So for example, we are using the revalidate property and setting it to be 1 hour because it's in seconds, right? We're setting it to be 1 hour. So the after 1 hour, this cached content will no longer be cached, and we are going to go ahead and regenerate the page the minute the user specifically goes to that page. But not on the first request, because on the first request, it is going to go ahead and request the page to download and get the latest complement. And in the second request is when you get the cache data again. So this specific get static props example really conveyed the idea how powerful incremental static regeneration is. Because you really get the best of both worlds. We are still caching one ID, but we are also getting and generating newer and newer IDs, and it's also cached for the next hour or so. So definitely check out incremental static regeneration if you haven't already. So if you have thousands and thousands of pages, then it really helps to essentially have the best of both worlds. Next, image optimization. Now, it's extremely important to make sure that images are optimized. Our web is full of images. Our sites are full of images. Images are really good visual content that really help understand the site better, right? If you have an e-commerce website, then an image will really help you a lot. It's full of images on that specific web page. In the entire site, you have a lot of different images. Now, it's extremely important to make sure that you go ahead and optimize those images. Otherwise, your site's performance is really going to suffer. So here are 2 ways which I think you can easily go ahead and optimize your images. One is cache images on CDN. So it doesn't matter if you have an e-commerce site or not. If you do have an hero image, for example, you can easily go ahead and store that image on the CDN. That way, it is not going to go ahead and fetch a new image every time. It's just going to return the cached content. The next thing is using source set. Next.js image component is really powerful. It is also going to go ahead and based on the viewport, it is going to download the specific image. But you can also provide source set, provide also different breakpoints to Next.js as well, and then provide the necessary images as well. So that specific viewport will have a specific image. So that on a mobile device, you're not downloading a huge image for a desktop, right? You don't want the image to pixelate as well. So that's the advantage of Next.js image component, but some of the image optimizations that you can do here. And lastly, caching. It's incredibly important to cache your site if you want performance site. Performance is equivalent to caching. You can cache, you should cache whatever you can cache. Think about it this way. How much stale content can you have? If that content can go stale for a little bit, go do it, because that is going to help you a lot, especially if you have like millions of users. Imagine millions of users coming to your site and re-downloading content over and over. That is not something what you want. It is going to also put a lot of server load as well. So caching is extremely important, especially in the case of server-side rendering. Now this function is get server-side props. It's extremely important to essentially combine server-side rendering with caching, because using server-side rendering without caching can really lead to poor performance. Every millisecond matters. Now imagine in server-side rendering, you are refetching content each and every time from the server. This is putting a lot of load on the server. By setting the specific response header to be cache control, it is going to go ahead and only fetch content every so often. It's not going to fetch on each and every request. So this value is considered fresh for the first 10 seconds because of the max age property. But if a request is repeated within the next 10 seconds, the previously cached value will essentially still be fresh, right? But if the request is repeated before 59 seconds, the cached value will be stale. But after, it won't be, it will be fresh. And that's the advantage of stale while revalidate property as well, where we have set it to 59. So the cache value will stale, but still render because of stale while revalidate. But in the background, it is going to go ahead and make a revalidation request to populate the cache to the fresh value as well. So if you refresh the page, you will see the new value. So that's the advantage of setting cache control headers with server-side rendering, because you don't want your performance to be impacted at all. Now, and having said that, that's all the 5 things you can do to take your next app to the next level. But bonus for you, there's one more thing that you can do to take your next app to the next level. And that is I have built a Next.js course that takes every developer from a beginner developer to all the way to an advanced developer, a senior developer. So definitely check this course out. A lot of hard work has gone into that. You are going to be really confident with Next.js towards the end of this course. And definitely check this link out, because if you do, you are going to also take advantage of some discount that I have specifically created for this specific conference. As part of this course, you will be learning not just the fundamentals of Next.js, but you will be also building an application like Netflix, which is a pretty complex app in Next.js, but also learning technologies like Hasura, serverless magic, functionality, database, serverless functions, Framer motion, and so on. There's lots more to check out. So definitely do, and please let me know on Twitter if you do like it and if you do check it out, what your thoughts are, and so on. Anyway, having said that, thank you so much for listening and have a really fun time at the conference.
Hi, I'm Amy Dutton. I'm the creative director at Zeal.
Hi, I'm James Quick, Developer Media Manager at Auth0. Now, Amy and I are the co-hosts of the podcast Compressed FM, a weekly podcast about web development and design. And we both love Next.js. But we figured, don't just take our word for it. We wanted to pull together some highlights from different members of the community, creators, if you will, and have them share why they love Next.js and how they've used it. Now, you'll hear from people of all different backgrounds and experience levels, so I'm really excited for you to get to hear from these creators. That said, let's go ahead and roll the tape.
I'm Shonda Person. This is Dr. Adonis. I'm a senior software engineer at Netflix, and I'm using Next.js to rebuild my personal site.
Next.js has definitely been a game changer for my developer workflow, where I feel like they keep nailing it with intuitive developer experiences like data fetching methods, which has helped me in my project Next.js WordPress Starter pull in all of my data from a decoupled WordPress instance where I can manage that headlessly and then deploy a Jamstack application all powered by Next.js.
Hey, this is Drew, founder of Protege.dev. We're using Next.js to build inclusive job board.
Hey there, I'm Avnish and I started programming almost a year back. I started with React and moved on to Next. The transition from React to Next.js was very smooth and I've been loving it because Next is so fast and the development experience is pretty good. I have built some great production-ready apps with it and I'm looking forward to learning more about it. I hope you also enjoy Next as much as I do.
I used Next.js to build Roll Your Tweet. It allowed me to move swiftly and create an MVP in a short amount of time.
Hi, I'm Catherine Peterson and I'm a software engineer at GitHub. Next.js is my go-to framework for side projects because of how great the developer experience is. I've always loved React, and Next just adds another layer of awesome features on top of it, like server-side rendering and built-in routing. Last April, I used Next.js to build a side project called readme.so, which ended up landing me my current role at GitHub. Because of how easy Next.js was to use, I was able to build and launch the whole thing in just a couple days, and that project ended up changing my life by landing me my dream job.
I use Next.js to build a newsletter app with Twitter review API and Tailwind CSS. I use it for my website.
Thanks to Next.js's API routes, I was able to add Stripe to the new better.dev website, and I was able to take payments in about 1 hour. So I went from 0 customers, $0, to having 1 customer and a little money in very little code. And that's thanks to Next.js's ability to do full stack apps.
So one of the things that I really like about Next.js is the way it allows you to handle routing. Next.js uses a file system-based router, and all you have to do is create a pages directory, and that's it. Any file you put inside that pages directory is now a route. It's really that simple.
Hello, this is Alex from codingcat.dev. I use Next.js and Firebase to build our site. It is easy to create our static podcast pages and dynamic admin pages using Next.js. CodingCat is open source, so feel free to check it out today.
Aloha everyone, Cap here. So I wanted to upgrade my portfolio, which is originally built with React, to now be built with Next.js. Why, you ask? because with Next.js, I can statically generate an SEO-friendly portfolio. So Next.js allows my portfolio to be served as HTML, awesome, be Googlebot friendly, great, and get my portfolio ready for more eyes to be on my work. All great things.
Hello, I'm Leandro, Community Manager at Swell. In e-commerce, there's always been this classic tension between getting your site up and running quickly and keeping things flexible as your business needs grow. Today, I'm going to show you how one of our merchants achieves this balance. But first, some context. Historically, we were forced to either build our own custom solution and therefore reinvent the wheels of commerce, or be beholden to an opinionated, rigid solution. Next.js and the Commerce Starter Kit provide the necessary framework. What's still required is an e-commerce platform that matches the flexibility of Next.js. Even if the platform has a headless option, the API might not have full access to the things you want, or you are not able to use it the way you want to. Here's how Villabici, one of our merchants, gets their Next.js site up and running quickly whilst maintaining the flexibility to add on new features. This store has all of the great out-of-the-box features you've come to expect with Next.js, like static site generation, for example. Here you can see the preloaded categories and their corresponding products, which all load fast. Unlimited variants are standard. Shipping rates are already calculated. Something that's unique to Swell is that there's an unlimited amount of currencies and localizations you can configure within a single store. Let's select Japanese yen. You'll see it change the value on site, but you can also be billed in that same currency. Something that makes an appearance in the Next.js Starter Kit is the wishlist feature. Velobici chose to implement it on our Swell backend. Adding items to a wishlist is simple. Everything on the wishlist is reflected on a custom model on the Swell backend. You can also see the raw JSON model. Something really cool is the Explorer, where you can see how your model relates to everything else. You can create custom models like product comparisons. Using a coffee quiz as an example, you can see how an API endpoint is automatically generated. Let's go ahead and add some fields to this quiz that we'll use as answers. Things like number of cups a day, and additional options like chocolate and berries. Something else you might want to add in a scenario like this is a lookup to your customer. Here we'll use customer accounts. Nice! Now we have our coffee quiz. You can customize the user interface with a preview of what it looks like. That UI can be brought into your Next.js. Here you can access your data fields and raw JSON. At Swell, we adopted the same pattern when we developed our new website and documentation center using the powerful combination of Next.js with Sanity and Tailwind, plus a flexible e-commerce backend. The API reference in the documentation is built on top of the same custom model that we just demonstrated in our example to use on your own storefront. We're always pleasantly surprised to see what the community creates and can't wait to see what you come up with next. Learn more about how Swell and Vercel work together in our featured blog interview.
Hello everyone, I am very excited to be here at NextConf, and I just want to take a second to thank you for checking out my talk. Now there's a lot of important things that you could be doing in your life and in this event, and you chose to take the time to hang out with me, so thank you. So let's go ahead and get started. My name is Nader Dabit. I'm a developer relations engineer at Edge and Node. I just transitioned into the Web3 space about 6 months ago. And this talk is going to be a combination of what Web3 is and also how to build an app on Web3 and what that stack actually might look like, especially maybe coming from a Web2 background like myself. So my talk is called Defining the Web3 Stack. And to define the Web3 stack, I first want to talk about what Web3 is from my perspective, and then we're going to look at the actual stack and the different protocols and the tools to build out a Web3 app. So let's talk about what Web3 is, and you'll often hear the word Web3 used interchangeably with the decentralized web. So typically when you hear Web3, you'll hear decentralized web and vice versa. Let's learn a little bit more around why that is the case. And what Web3 is to begin with. So a lot of times when you hear people talk about the web, and especially recently with Web 3, you kind of hear them partition the web in three separate phases: Web 1.0, Web 2, and Web 3. So Web 1 was kind of typically known as the read-only internet. This was when if you wanted to create something, you had to be a developer, and everyone that was using the internet at this time was essentially just a consumer reading text and not really contributing back and creating anything. And most of us have experienced the web as it is today. And this is typically known as Web 2, or this is kind of like what it's bucketed as. And Web 2 is kind of the user-generated creator web. Anyone in Web 2.0 can be a creator. You can create a blog post, you can create a YouTube video, you can create, all kinds of stuff. And it's extremely amazing, really. And we've really done a lot of amazing things with Web 2, and it has really changed the world. And with that being said, though, there are some areas that a lot of people think it can be enhanced. And that's kind of where we're going to get at with Web 3. And I want to talk about what are some of those areas where people are excited about Web 3, what those advancements may look like. So when we think about the internet and how we as developers have interacted with the internet and how we build websites, really, the internet has kind of thrived because of native protocols that we use every day. So things like HTTP, FTP, TCP, SSH. One of the reasons that these protocols have been so successful is that they're so widely adopted and they're not subject to change. If I build a site using HTTP, people can use it without any centralized intermediary. And we can trust that everything is just going to work. And while we have had all these protocols and they've been really great and we can do a lot of stuff with them, we essentially have the ability to upload text files, attach them to addresses, make them accessible. There were actually two major pieces of functionality that have been left out up until recently, and that is native payments and native state, internet native payments and internet native state. So to get around this, what have we done? Well, think about how payments work. How complex is a system like PayPal in order to get payments from one party to the other globally? Now, let's think about a situation where we have two people that turn 18. One of them is in the United States and one of them is in a different part of the world. How can they send money to each other using the legacy systems that we have today? Well, basically, first of all, they have to go get some form of identification. Then they need to bring, of course, a lot of information with them to get that. They then need to go to a bank where they take that information along with some money, and they go through a process of getting their information into that system. Of course, the other party has to do all of this work as well. Then they might go home and go on the internet and create an email address, and then they might then go sign up for PayPal. Maybe PayPal actually isn't accepted in that country, so they'll have to figure out, what payment system is actually going to be working between both parties. Now, I'm not even done yet, but how complex does this actually sound? Well, it is complex, and there's actually even so much more complexity that's going on under the hood to make all of these systems work. What if instead we had some native way to send payments? Well, that's essentially kind of what blockchain technology is enabled. It's also enabled native state. So instead of how do we deal with state today? Well, we build a database. We might have a database sitting in our garage, but we might go to something like AWS, which again is really great, but it's very, very complex. It's also centralized. So if our database goes down, our application goes down, meaning no one can use it and no one can access it until if or when we can get our API, database, and server back up and running. We now have a single point of failure. What if instead the internet had native payments and native state built in? Well, this is really the foundation from which Web3 is built upon. And with the advancements of smart contract technology built into blockchains, as well as the ability to create digital scarcity, we're starting to see a lot of really interesting stuff happen in the past couple of years. So Web3 is kind of like the evolution of what we've had before, along with these new protocols. And a couple of the characteristics that you often hear around Web3 fall into some of these different areas, but this is kind of my rendition of that. So decentralized is something you'll hear all the time. And it's not only decentralizing the web infrastructure and decentralizing opportunity, but it's also decentralizing ownership. So instead of having corporations or organizational structures where 95 or 90% of the ownership is in a very small set of hands. A lot of the protocols that I've worked with and I've seen, and a lot of the DAOs that I've interacted with, spread that ownership out across a lot more parties. There are a lot lower barriers to entry to gain ownership. And a lot of times people that in the past were locked out of these opportunities are getting them, and they can create them for themselves without a lot of gatekeeping. Native digital payments, we'll go into some of that in just a moment. Self-sovereign identity. One of the big problems with Web 2 has to do with the fact that our identity is handed over to so many centralized intermediaries, and they store that in hundreds of databases, depending on how many applications we've signed up. And they leak that data, and they're also gathering all types of other information about us via cookies and other types of invasive ways of tracking us. And they put all this information together, and then it leaks out, and then we have all types of problems because of that. One of the very, very interesting things to me around Web3 is distributed, trustless, and robust decentralized infrastructure. Someone coming from the serverless world, I truly realized that a lot of the Web3 technology is really just serverless, in the sense that we have these protocols that are building out and creating the web infrastructure that we might have used from a web company like AWS or GCP, but instead it's truly decentralized in the sense that if 1,000 of these servers go down, my application may still be running. Really, two really interesting areas as well are open and public backends, meaning that if I choose to build my application in this manner, I might have the opportunity to build out my YouTube channel instead of hosting it on YouTube. What if instead we could have all of these videos being hosted forever on some distributed, decentralized backend that not only I can take advantage of, but other developers can compete and build interfaces on top of that data. Similar to kind of what we're seeing already in the DeFi and in NFT space, in the Web3 space, we're going to see a lot more of that same stuff happening in other parts of Web3. So let's talk about those parts of Web3. What are the types of applications that people are building? Well, let me give you some examples of areas that I think are good ways to kind of exemplify what the benefits of Web3 are. First of all, let's look at gaming. Fortnite is one of the games that I've found really interesting. This is not a Web3 game. This is more like an example of how we can Web3ify a game. My children really love Fortnite, and typically I would pay like 70 or 80 bucks for a game, and then that would be it. But not with Fortnite. Fortnite actually has in-game currency, but also in-game skins. And I spend hundreds of dollars a year on Fortnite skins. And this is cool because my kids have a great time. Of course, it's not that cool for me because I'm spending a lot of money. But the interesting thing to me is that 100% of this money is going to the game. And nothing can ever be taken out of the game. No matter how much money we put into it, when my kid walks away from that at some point, and he outgrows it, we've just given billions of dollars collectively to this organization. Now, what if instead we had a way to hold on to some of that value? So Axie Infinity is a Web3 game that actually implements a lot of these ideas. So instead of us dumping money into this game and the platform walking away with all of it, instead, players in this game can earn tokens, so they get paid to play. They can also breed Axies, which are kind of like these items that can be resold and with outside of the game. They can invest in land. They can farm tokens, and all of these tokens and all of this stuff is actually available to resell in a liquid market. 95% though of all of this money actually goes back to the users. There are people that have quit their jobs and are now playing Axie Infinity full time, making a lot more than what they would have made in their homes in places like Philippines and different parts of Asia and other parts of the world, where it is really hard to actually make money or make this type of money, I would say. So that, to me, that's extremely interesting. And Axie Infinity is like not only interesting, but it's actually extremely successful. They now have over 2 million daily active users, and the last 2 months, $500 million and $700 million in a month of actual transaction volume. So this game has actually gotten the attention of a lot of other game people in the industry. So for instance, Ryan Watt, head of YouTube gaming, said, "I'm bullish on NFTs. I believe that play to earn is the next major gaming model." You also have Mark Pingus, founder of Zynga, that says play to earn and play to win is the next evolution of freemium. Now, not everyone is kind of believing this or going this way in the gaming industry, but you're starting to see a domino effect of people realizing this. And there are a lot of investment also happening from A16Z and other different venture capitalists into this area. Another really interesting application of Web3 technology or blockchain or crypto is DeFi and stable currencies, and how you might build applications using this stuff. Financial applications, of course. So what does this solve? Well, it solves a lot of stuff, but let's just take a look at a couple of use cases that are important to me. One is inflation and government crises. So right now, Lebanon is actually going through a really, really massive political crisis, but it's been going through an economic crisis. Over the last 2 years, 90% inflation, meaning that if you had $100,000 in your bank, it's now worth $10,000. So why not just take it out 2 years ago? Well, you couldn't. The bank actually would not let you withdraw your money. So I have family and friends from Lebanon. A couple of them are now economic refugees that have had to leave the country and go elsewhere to find work because they've lost their businesses. Some of them have lost their homes and their life savings. And that's not even the worst. I mean, Venezuela, if you've been keeping up, is also quite a disaster. 10,000% inflation rate. So what if you could have some stable currency? Well, one of the really interesting things about a lot of the tokens is that there are stable coins pegged against something that is stable like the US dollar. And a lot of people are now asking and getting paid, especially digital workers, in stable coins. This way they can hold on to the value and they're not getting fucked by their governments. Another thing that's really interesting to me is how do we solve the problem of the 1.7 billion people that in the world that are unbanked? Well, there's a lot of reasons why these people are not allowed access or that don't have the privilege like we have, a lot of us, to have access to banking. Let's take a look at one of them. One of them is discrimination. In the Global Gender Gap Report of 2020 from the World Economic Forum, there was a study, and they found that there are still 72 countries that do not allow women from certain social groups to even open a bank account. 72 countries where women cannot open a bank account just because they're women. This doesn't even go into a lot of the other stuff around why people are unbanked, but this alone, to me, says a lot. And if there is a way to kind of help solve this, and there is, then let's go ahead and make it happen. So with Web3, you can actually jump into a Discord and literally jump into a conversation and meet people and start, working and getting paid in tokens. Let's imagine a world where even Web2 companies would pay someone in tokens. Then people can, start actually making money, having a stable currency as well if they choose so. And the biggest challenge at this point is that not every digital platform takes and accepts these tokens. So how do you actually turn those into a way to spend your money like in your hometown to buy groceries or something? So that's kind of like the next step, but there are a lot of ways to cash out depending on who you know and things like that. The people I know in Lebanon, there are people there that help them offload, digital tokens and stuff like that. But ultimately, I think the goal would be able to kind of have more of a liquid exchange between local fiat and these stable currencies than we have today. And they can actually use these tokens and participate in the economy as well, not just having it to kind of live off of, but let's say they wanted to participate in the banking system, even though their local country doesn't allow that. Well, they can participate in DeFi protocols like Curve, which has $17 billion in liquidity, Aave $28 billion, and Uniswap, which has a total of $386 billion traded, doing lending, borrowing, and all types of other interesting stuff in finance. Another area that is really interesting to me that we're still kind of seeing is social media. So let's take a look at social media and Web 2. Social media and Web 2 is built upon these three main ideas: exploitation of user data, advertising, and taking ownership from creators and using it to monetize the platform. So when you go to Facebook and you have a million followers, they're literally making so much money off of you, and the only thing that you're doing is sharing your image and getting 1 million likes. And then they take all of that traffic and they funnel it to advertising. And we all know a lot of the negative consequences around some of this stuff. So how can we kind of change this? Well, let's take a look at a few ideas. And I think they all really come down to this idea of ownership, and this ownership model is enabled often via tokenization. So let's take a look at some platforms that are using tokens to give back to users for participating in their platforms. Super Rare is really interesting to me because it started off as like an NFT platform where digital artists can go from around the world and sell their art. Anyone that used Super Rare, though, over the course of a certain amount of time after they launched, when Super Rare became successful enough to launch their own digital token, they decided to airdrop and send tokens to all of the people that had used the platform. So just from actually opening the app and using it, you would have received anywhere between a few thousand to some people received over 100,000 US dollars worth of tokens just for using the platform. The way that a lot of these Web3 platforms are built to enable models to where these types of mechanisms can happen. And this is kind of just a look at how they might take some of the liquidity that they've made in the platform and give it back to their users. But let's look at how users can also come in and make money as well. But before we do that, let's take a look at one more example. Gitcoin is a way for developers to go and get paid for their open source contributions. When they finally did a token launch, they launched their token and then airdropped over $100 million to their users as well. All you had to have done is been using the platform. But let's look at how someone with a platform might use that to make money. One artist, and he's a developer actually, his name is Takawa Shinsuke, and he's also an artist. But he used P5.js and JavaScript to create this generative art collection. He wanted to find a way to give back money to the communities that had kind of helped him build his career. So he built this NFT project, 432 lines of JavaScript, and he launched it. And it sold over $3 million in sales in just a few minutes. All of that money went back to the different communities that he was a part of. And people that wanted to contribute to this community had an opportunity to kind of buy these NFTs that were then available to be sold on a liquid market. So why not just do a fundraiser where you ask people to give you money? Well, we all know how well that often works. Unless you have like a really, really huge following and you're have some type of extra privilege or something, then it's really hard to get people's attention. But when you're giving them something that they can have a value and then maybe feel like they have ownership in something, then it provides a new incentive structure. So I think that's why this project was so successful and other ones like it. And now when anyone sells one of these on the open market, they also take a percentage of it and give it back to the community as well. So every transaction after that also does that. And if you had bought one of these, I think it's worth maybe 1.5 to 2 times as much as it was maybe when you bought it even. So not only does the person that launched the project and their community benefit, but the purchasers also benefit. But how does this actually apply to social media in general? Well, I think that we're going to start seeing the way that this happens in the next few year or two. But I truly think that there's going to be a big Web3 social media platform that is successful. And I think it's going to happen from a digital marketplace or maybe a wallet, which is something we'll look at in just a moment. So even Jack, even though he doesn't use the term Web3 at all, he is also building a decentralized Twitter because I think he's starting to kind of see the writing on the wall. And then you also have the founder of Aave, who is they're a Web3 company that have built out really interesting stuff so far. They're also working on a decentralized, quote unquote, Twitter. So I think we're going to see what this looks like sometime, hopefully soon. So in addition to the things I kind of outlined, I think you're just going to see the Web3ification of existing applications. That doesn't mean you're going to have to leave your Web 2 platform if you like it. I think people are just going to build alternatives, and you're just going to have more options. And people that want to try to get away from the advertising model, will be able to do that. So more options, I think, is always a good thing. And I think DAOs are also very interesting, but it's kind of beyond the scope of this. But it's kind of a new way to enable ownership within communities. So a couple of other really quick examples is Audius, which is kind of a Spotify Web3 alternative, which is pretty interesting. Mirror.xyz, which is kind of like a blogging platform that allows users to earn tokens by using the platform and also to do fundraising and crowd sourcing within the platform. So how do we build these applications? This is really what the talk is all about. Now that we know the types of apps that we're building and we understand some of the use cases maybe. Well, I mentioned distributed, trustless, and robust infrastructure. Let's look at some of that infrastructure. So when I think about the Web 2 stack, I think about identity, I think about API, I think about all these different things. So let's take a look at those in the Web 3 world. So let's first take a look at the API layer. When you're thinking of blockchain data for the most part, and this is just like one part of the stack, you cannot query blockchain data efficiently directly from the chain, mainly because these data structures are not indexed like a typical database that is there for efficient querying and retrieval. You instead have these blocks that have been written over the course of days, weeks, months, and years. Now, how do you query that and get like relational data and all types of other queries that are typically necessary? Well, in the past, people would index all of this information into a centralized server and then serve it up from there. But this kind of broke the important security mechanisms required for true decentralization. It's also very engineering intense work, and also it just takes a lot of time and effort. So the graph is actually a protocol that I work with, and the graph allows developers to launch these subgraphs which index data and do it in a decentralized way on a decentralized network of nodes and serve up this information for web applications. And there are a lot of interesting applications in Web3 and DeFi that are using it. So that's kind of like the API layer for blockchain data. Then you have off-chain data. There are a couple of examples of protocols that are kind of handling this. So this would be for information that you do not want to store on-chain. So maybe you could think of things that are maybe not as important. So Ceramic Network is really interesting. And they also have a protocol that you can combine with Ceramic that I'm just going to show in just a moment that enables different various types of user identity management. So off-chain data would be something like Ceramic Network. Live streaming, well, LivePeer is a really, really interesting and successful decentralized live streaming platform. It also runs a network of nodes that allows you to process and stream video. And it's actually at least 10 times cheaper than any other centralized alternative. I had one of the founders on my YouTube channel not long ago, and if you want to learn more about LivePeer, I would definitely check out that interview. He was a really, really great guest. What about file storage? So we might think of something like S3 for file storage. Well, in Web3 space, there's a handful of them. The two most interesting ones to me are IPFS and Arweave. IPFS is a decentralized file storage network, but you're not guaranteed a lot of times like how long these files will be stored or pinned. Now, there are different services and different protocols that kind of try to make this long living. But at the end of the day, it is hard to determine how long these files will be available. So another option there for something much longer lived is Arweave. Arweave is a protocol that allows you to store files permanently. And you can store blog posts, images, all types of stuff. So you pay a single transaction fee. I think for a 1 megabyte section of text is like 4 cents or something like that. But once it's stored, you never have to pay hosting fees ever again. So you could launch your blog and then never pay anything for 20 years and it's still going to be working, which is, to me, pretty interesting. For Get source control, Radical is a decentralized network. They have their own tokens as well. I think one of the really things that we could dive into a lot in a completely separate talk is kind of how you deal with identity. And how identity works in Web3 is just so much different than what we're used to. What we're probably used to is handing over our email address or our phone number or something to authenticate, maybe via OAuth or via some form. Well, with Web3, you're typically using something called public key encryption. And you're given an address that you can use to essentially kind of authenticate with using some type of wallet for the most part. MetaMask and Rainbow are pretty popular wallets, also Phantom for Solana network. And you basically can just install one of these wallets in a Chrome extension. When you do that, you're given a seed phrase. The seed phrase is kind of a way for you to unlock this wallet anywhere in the world. That seed phrase is something you keep very private, but using that seed phrase, you can determine a private key, and a private key that you're given can then determine your public key and your address. And using those 4 things, you can authenticate, you can sign transactions, You can also send transactions to a server and allow someone to parse that transaction using that address and that public key. So authentication all has to do with a wallet and public key encryption, I guess is kind of where I'm getting at. And you can decide to identify yourself via your address or not using a protocol like IDX, which is something that also I find pretty interesting. So let's say you do want to tie some information like a username or something, and you don't want to hand it over to like every website individually. You can actually use something like IDX to set that user profile, and then when an application wants some of that data, you can decide to point them to a certain profile that you have complete control over, and you can decide which information, and what to share there. So those are all some pretty interesting protocols that fill in some of the stack. But essentially, when you think about Web 2, you have compute, identity, data, storage, and web hosting. I think that's kind of the main things you would typically need for most applications. Well, with Web 3, you really have the same thing, but you now have this additional idea of smart contracts, and you're also aiming to build all this other stuff using decentralized infrastructure if you're kind of trying to build a truly decentralized app. So with all of that taken into consideration, you don't have to kind of build fully decentralized applications. You can kind of take some of these ideas from Web 3, combine them with Web 2, and build out interesting ideas as well. Now, most of us, including myself, are kind of pro fully decentralization, I would say. So like we're trying to get there, and we are there in a lot of aspects. But there are areas today where you kind of have this idea of progressive decentralization, where you use kind of like what is available now to build the types of experiences that you want to build. So what does like building a dApp look like right now then, if you wanted to kind of just get started? Well, I would recommend starting off with like the bare minimum. It would be a client framework. You would choose a blockchain that you want to build on. Typically, of course, something like with a smart contract so you can write actual code. Some type of client library and some type of wallet. Now, when you're thinking about a blockchain, there are a handful that are gaining popularity. But I think for me as a developer that wants to write actual code that executes, these are some of the more interesting ones that are starting to gain popularity and that have fairly good either documentation or communities out there. Ethereum, Avalanche, Solana, Phantom, and Near. Those are all really, really interesting to me. Tezos is also kind of interesting. I think one thing to keep in mind, though, is there's this idea in JavaScript or in React where you can kind of learn JavaScript or React once and you can write it anywhere. And you can build all types of applications, Well, in blockchain, Ethereum and EVM is kind of a similar role. EVM stands for Ethereum Virtual Machine. So you can learn this Solidity EVM toolkit and environment, and you can actually build applications on various blockchains, like over a dozen different areas. You can do Ethereum, you can do Optimism and Arbitrum, which are Ethereum layer 2s. You can build on Avalanche and Celo. You can build on Polygon. You can build on like a handful of different blockchains. So that's kind of often a very good place to start, learning EVM, Solidity, and Ethereum, and then you can kind of build in a bunch of different areas. So to get started, I would recommend like the starter Web3 stack would look something like this. Use a client framework like Next.js. You can have Hardhat, which is a really, really interesting Ethereum development environment. You could almost think of this as like the Next.js of Ethereum, where you kind of like get all this great stuff packaged for you, and you can do all kinds of stuff, and you don't have to kind of run all of that code and do all that stuff yourself. It's kind of packaged in. Ethereum client library, Ethers.js, is something like Fetch or Axios in the Web3 world. And then a wallet to get you started might be something like MetaMask. I'd also recommend checking out Scaffold ETH, which is a GitHub repository run by Austin Griffith. And there are over, I think, 200 branches in this repository. And each branch is like a separate application built from scratch. So you can kind of see how to build, token exchanges, DeFi projects, governance, DAOs, all types of different really interesting applications are there. Another one is Solana, and using the Anchor framework is kind of like a hard hat version of what you might want for Solana. And this is just another great place to start if you're looking to kind of learn Solana development, to check out Anchor. And if you want an end-to-end guide, I would check out my tutorial, The Complete Guide to Full Stack Ethereum Development. It's been read over a couple 100,000 times across various platforms at this point. And yeah, that was a lot, but that is it. So I just wanted to say thank you for your time. I hope you learned something, and I hope this was interesting for you. And yeah, thank you for checking out this talk, and I hope you enjoy the rest of NextConf.
Hi everyone, thanks for joining my talk today, and I hope you're enjoying the Next.js Conf. I'd like to talk today about how Next.js scales to millions of pages with incremental static regeneration. But before we dive into the talk, let me very quickly introduce about myself. My name is Arisa Fukuzaki. I'm a developer relations engineer at Storyblok. Besides from my work, I'm an ambassador of Girl Code, as well as doing some podcasts on my own to interview some of the interesting developers. Also, I'm an organizer of a Japanese tech community. If you have any questions related with Storyblok or headless CMS in general, you can text me anytime. My Twitter's DM is open. My username at Twitter is Arisa_dev. For today's talk, we have a special guest from Education First. Telmo is a solution architect at Education First. Education First provides language trainings all over the world. Also, Telmo has the experience of architecting and implementing headless CMS as well as the e-commerce solutions to the enterprise scale of the projects as well as small businesses. We would like to invite Telmo for this talk right now.
Hey, Arisa, how are you?
Hello, Telmo. I'm doing great. How about you?
I'm doing really, really good. I'm happy to be here and share a little bit of our story with this great crowd.
Thank you for being here too. So I have a couple of questions would like to ask you about. So first question would be, what was the challenges that you were facing?
Absolutely, all of them. So if we go back in time 4 years, and what actually is a 7-year story, but at this time, we were heavily invested in a very solid enterprise CMS, and functionality-wise, we thought that we had a very good fit for the company. Yet somehow, and with years of usage, we still felt slow on deliveries. Every time we looked closer as to why, we always saw that this was true for most roles that interacted with the system, and moving away from it felt like pushing an iceberg across the globe. So we spoke with other product teams just to make sure that it was not just a problem on an island, and we saw the same reflections. Editors, backend, front-end developers, and of course, even stakeholders all shared different levels of the same steep learning curve. Documentation was insufficient, and certifying the personnel only covered a little bit of the essentials. So at this point, it was also very hard to get truly specialized knowledge. Even hiring certified contractors meant looking through a very reduced pool of professionals, and much in the same manner, editing content, creating new back end code, and working on the front end was extremely slow. So we had challenges across the board, but at the root, delivery speed was the main problem to solve first. And unfortunately, the CMS was often in the way. It was quoted by teams time and time again as the reason as to why something was not executed on time. So if we pile all of that, and at the time, another heavy ambition of ours, and one of our current focuses still, was to be great at content personalization. And we knew back then that we needed to be particularly limp to experiment and to tackle that one specifically. I hope that answers your question.
Yes, of course. That was really nice stories that you shared with us. And based on what you told about us, I would like to ask you more about why you chose the headless approach and why you chose the framework to go with Next.js.
Absolutely. We were not blind to the market shifting towards headless. So there is that. And that in itself gave it authority as a movement because it was new ground territory and most of the products were still in their infancy. Still, we understood having the flexibility of accessing an API to reach structured content and use it across mediums. It was very appealing to us, and this would give us maybe a new breath in tackling different projects. This is what we felt then. This is what we see today. So when we first looked at it as an option, we realized very soon that this would give us the ability to use it as a traditional CMS, meaning we would structure and model data around routes, and then we get a website or get a web app. But also, now we can do content repositories when it fits the product, when it fits the purpose. We can do content repositories, and the schema then is not built around having a single medium as an output. It could even be across teams and across products. And this is very enticing, very interesting aspect of the headless CMS is that you can just model your content once and use it in a different amount of mediums and devices. Much in the same manner, even internally, we can then graph these content repositories and create new ones specialized to specific market meta. We've done more and more of this type of work, and it's really worked beautifully for us. And having a programmatic API that can hook up to and handle the component schema and content migrations has been a bliss for automation. And it's one of the things we were aiming at. We really struggled either with serializing data between environments or in some cases genuinely cloning it because the systems did not allow us to do this. Headless, of course, and more aligned, I guess, with the next topic. Headless allows us to choose the templating framework for the individual team, project, or overall company. And I have to say on my team, we're very much on the next boat, and we're very, very happy with the output with using this framework. And it synergizes a lot with our current user pool and React. So a lot of our developers love React, and to be able to execute their work in that framework is great for them. And to do it in Next with a product that just builds upon React and has the output quality from the Next team, it was just bliss. So we can spin up projects much faster. And then the headless approach for us as a topic, it doesn't really gather too much responsibility. So one thing we were seeing with the systems we were evaluating is more and more they were gathering responsibility that arguably could or could not be in the CMS, such as analytics, A/B testing, personalization, making it simpler and faster to develop if you don't have to think about those. If you don't have to think about those to make a component, to make the front end, to deliver a piece of code, of course, you can then use best of class tooling for those purposes and achieve a better output. And this was something that we were strongly believing in. And this is something that we still pursue today. So I would add, finally, that in spite of the headless aspect of having a UI, or in spite of the headless aspect, having a UI to preview and edit content was definitely a selling point for us, making it a solution that is easier to be accepted across different minded professionals. So for context, our larger product sites has about 211 registered editors over about 60 markets with different backgrounds, roles within sales, marketing, and technology. And it makes it a lot easier to present a UI to sales and marketing, for instance, but also to developers in order to execute a specific task.
I understand what you share the stories with us, because to distribute with such huge scale of the project, with such a huge numbers of 211 of the content editors, would be very difficult to control all. And based on that, I would like to ask you one more question. What was the progress and learnings you had since you started to use Storyblok as a headless approach for over a year?
Well, I have to say we're very happy with the results so far. So as you know, we've successfully recently, about a year ago, ported our larger product websites to be static rendered. And in this project, that we saved for a later stage because a number of requirements, both with the business, but also features pending in the CMS needed to be met. So we started with a lot of confidence after we met those requirements. And then even having multiple projects that use server-side rendering to provide editors with a real-time preview, but with the changes that they've done in spite of being static rendered, that is definitely something that we're very, very happy with. If we can enrich, I mean, we recently delivered a piece around personalization that uses Storyblok and allows us to deliver enhancements in real time to websites based on customer actions and attributes. And again, this is happening in real time in spite of having an inherent static nature. So we can enrich as we need, which is absolutely great. And another pinpoint for us recently was that we've developed a product information management system around Storyblok, and we put an API facade in front of it, and we have a front end for Next. So we have a much richer, much more custom experience for our content editors to create content around our products that then can be distributed centrally to multiple platforms. And we see the teams finally having time to properly focus on front-end development, on product development, on back-end development, and improve their development experience. About, I guess, learnings. What did we learn? We learned to use fewer monoliths, to advocate for best-in-class platforms and mix them for the best possible results. This has been key in getting the agility that we have today. To integrate more, definitely to integrate with everything, really. There's been a heavy push on and focus on content APIs, but also in APIs in general. This has made it a lot easier to breach silos and to retrieve content within different products, different teams, and we're using it more and more as we go. We have been automating everything we can get our hands of. We also have an internal push for infrastructure as code that enabled us a lot for this specific purpose. And we really learned to optimize in caching API calls. So during static build processes, we can turn hours into minutes just by doing the right optimizations at build time. And for the volume of markets and pages that we output, that has been really key. It's been night and day since we've done that iteration. And so much more, but it's easy to think about examples, but difficult to condense. So if there's an interest, feel free to ping us for details.
Yes, of course. And it's really impressive that you minimize the build time from hours to such the short minutes. And that was really helpful solutions for other use cases to hear as well. And I really would like to say thank you for sharing your stories. And I'm really hoping to hear more learnings and the progress that you will have. So thank you for talking with us today, Telmo, and I wish you a good day.
Thank you so much. And thank you so much for the great product, actually. Both Next and Storyblok changed the way we work today, and we're very happy for that.
Thank you so much. So happy to hear that. Okay, so see you soon.
See you soon. Bye-bye.
As we heard the stories from Telmo, there could be some of the challenges that you might also face in your projects. One of the challenges would be, for example, if you have many editors in your team with enterprise scales or bigger scales of the projects, how you're going to handle all the changes at the same time in different markets. This could be a very serious problem. As one of the solutions we already know from such as PHP or monolithic world is server-side rendering. Server-side rendering will load the content at each request. So you will have the most updated version of the pages at any reloads. However, this could cause the issue of performance. There also would be the issue of the caching. you need to deal with these two problems if you're going to choose the server-side rendering. Another approach that we already have known is that static site generation. If you're already familiar with Jamstack, you may already have heard about SSG, or you even have some of the experience. Static site generation is loading the content at each build time. It means that unless you make the next build, the content will stay the same. Also, if you have a lot of pages to generate, the time of the build time is going to be longer. It could be from minutes to hours, and you're going to be blocked for these long build time. What if we have an approach, such as a solution with a hybrid features from server-side rendering and static site generation? And there is already a solution which is provided by Next.js. It's called incremental static regeneration. So for incremental static regeneration, in this diagram, you can see that you are able to choose the amount of the pages that you want to generate at build times. So instead of waiting for 2 hours to build over 100,000 of the products in your e-commerce project, your build time is now from 1 to 8 minutes. In more details of overview about incremental static regeneration, here in this diagram, you see that how it works in more details. Let's say we have two users. There is a user A and user B. User A visits the page right now. So user A will see the page which is generated previously. At the same time, while this user A visits the page, it triggers to generate the other newer version of the page, so that the user B who visits the page few seconds later will see the most updated version of the page. And that's how it works with incremental static regeneration. Now we took a look together how incremental static regeneration works in a logic. But we want to see how it works in an action. So let's dive into our demo. Here in the screen, you are seeing the visual editor from Storyblok, as Education First chose to use for their headless CMS approach. On the left-hand side, you are seeing the real-time visual editor. What I mean by that to say the real-time visual editor is that you will see the changes instantly. If I want to change the order of the components, you will be able to see the changes right away. While I'm making all these changes, you are not giving any impacts at all to the production environment. On the right-hand side of the screen, you are seeing the components. Also, you are able to add as many as components unlimitedly. So you do not have any restrictions to define the components when you need. When you choose one of the components, you will be able to see the field types, such as headline or image. Or if you want to have new field types, you are also able to define new. Let's say we want to change this headline to say something from Hello World to Hello Next.js Conf. You were able to see the changes as I typed. Also, if I want to replace the image, you also can do that very easily by choosing an icon of replace and choosing the asset of your choice. We made all the changes, so let's check it out when we publish the content and see how it works in these three systems: SSR, SSG, and ISR. As for the SSR, if we are going to reload the page, we are going to see the change on the fly, because server-side rendering will load the content at each request. As for the static site generation, no matter how many times we reload the pages, we are not going to see the updates. It is because static site generation will load content at each build time, so it will not change until I make the newer version of the build. As for the incremental static regeneration, if I reload for the first few seconds, you don't see the updated version of the page. It is because right now it's triggered to generate the updated version of the page. So if I reload the page right now, I'm able to see the updated version of the page. So while the user A is seeing the previous version of the page, it's already triggered to generate the newer version of the page. After a few seconds, the user B will be able to see already generated and updated page. At this moment, we were able to see the behaviors between SSR, SSG, and ISR. We would like to take a look at how you can integrate and configure in the source code level. So let's jump right in to the VS Code. Here in this repository, you see that I created 3 directories depending on the system that we are going to use. One is SSR, the other one is SSG, and the last one is ISR. Let's take a look at from server-side rendering. Here at the source code, we are seeing that one of the methods from Next.js. It's called getServerSideProps. In this scope, you're seeing that as a final value, we are returning the props so that we will be able to load the content at every request. Let's take a look at the static site generation. Here in the source code, we are seeing that there are 2 methods which are provided from Next.js. One is called getStaticProps. The other one is called getStaticPaths. In the scope of getStaticProps, here you see that the values which are returned at the end are very similar to what we took a look at in server-side rendering, and nothing more values are returned. As for the scope of the getStaticPaths, here at the end, we see that the value of the fallback is set as false. It means that if we create a new page in static site generation, we are going to see a 404 page until the next build, because static site generation is going to load the content at build time. Let's take a look at the incremental static regeneration. In this file, we see that the same methods from static site generations. One is called getStaticProps, and the other one is called getStaticPaths. The place where we want to pay attention more is, first of all, in the scope of getStaticProps. Here, in the end, returning the props are the same. However, we have a new value, which is called revalidate. As you set the numbers in here as the value, you're going to tell that after, in this case, 10 seconds, you are going to see the newly generated version of the page. However, within these 10 seconds, you are going to see still the previous content. In the scope of getStaticPaths, here the value of the fallback is no longer false. Instead, we are setting the value as blocking. It means that, well, for the first 10 seconds, we are going to see the 404 if we created the new page. However, after these 10 seconds, we are going to see the newly generated version of the page. And that's how you can integrate in your source code. We were able to take a look at how these three systems work and behave in the browser, as well as how we can integrate in your code. If you're going to deploy your project to hosting service, such as Vercel, instead of triggering your webhooks to rebuild again your project, as long as you make the change at the headless CMS side, you are able to see the changes at the production environment. Let's try it out to make some of the change from this headline. Right now, it says, Hello Next.js Conf, but I want to change this to Howdy Next.js Conf. And I'm going to publish this content. At the Vercel, we are able to take a look at the preview. Here in the preview, if I don't reload the content, of course, it's not going to change. If I reload once within these 10 seconds, the contents are still the same. However, as we deployed this project as an incremental static regeneration, if I reload after 10 seconds, it's going to show us the most updated version of the page content. And this is how incremental static regeneration works. If you want to test it out, this demo project in your environment, there is the GitHub repository available for you. You can get access from this URL. As a recap from what we heard the stories from Telmo from Education First, as well as what we have took a look at together, our demo, Education First chose to go for headless solution because, as their choice, Storyblok has the real-time visual editor, so that content editors will be able to see the changes on the fly. To integrate the frameworks of your choice, it's also very easy to do that because at Storyblok, we offer the packages available for you. So you do not have to build the package to integrate your choices of the frameworks into the headless CMS. Also, if you want to manage the bigger scale of the multi-language project, we at the Storyblok offer the internationalization as an option, so that you will be able to choose within 2 to 3 approaches that we offer. As Telmo shared his story with us, there is an easy onboarding process. As you have seen in our demo, it's quite straightforward to take a look at it and to learn how to use it, so that you will be able to provide the tools from the day one, and your team members will be able to use it without the long hours of the workshop. If you want to test it out right now, don't wait. There's all the resources available at our Storyblok's website. Here in this URL, you will be able to see hands-on blog post tutorials, such as multi-language blog projects, also 5 minutes integration. Last but not least, I want to say a huge thank you to Next.js team as well as the Vercel team for providing such an amazing DX and the framework. Also, I want to say a huge thank you to Storyblok team. Today, I'm the one talking. However, without the efforts and the support from my team, I wouldn't be able to do that. So, a huge thank you to all of them, as well as thank you to you all for watching my talk. Not to forget, we prepared a little surprise for Next.js Conf. If you go and get access to this URL, you will be able to enjoy our team plan for free and for 3 months. Although we prepared this little surprise for you, if you're a developer who wants to explore how Storyblok works, for 1 seat, it's forever free. So don't forget to test it out. And that's all what I wanted to talk today. I hope you enjoyed my talk, and I wish you will enjoy the rest of the talk at Next.js Conf. Thanks for watching.
Content, and I am really excited to teach you a little bit today about how to protect your applications in Next.js. So a couple of expectations. This is not a security deep dive. We're going to avoid buzzwords. We're going to avoid deep dives into identity concepts. This is specifically targeted at app developers, developers who want to build stuff and get things done, not security professionals. Also, a quick heads up. I am an employee at Auth0, so you'll see lots of references to our Auth0 SDKs in this talk. For the most part, the concepts that we talk about won't be specific to Auth0, so they can still apply regardless of if you use another tool to handle your authentication, authorization needs for the applications that you build. So let's start with what is the Jamstack. We've all been there before. You probably have a decent idea of it yourself, or maybe you don't. The interesting thing about the Jamstack is that there's really not a great definition for what the Jamstack is. If you ask everyone watching this video what their definition is, those definitions will probably vary from person to person. But we can at least start with the acronym. The JAM in Jamstack stands for JavaScript, APIs, and markup. Now, none of these things inherently are new concepts. We've had JavaScript for a long time. We've used APIs for a long time. We've used markup for a long time. None of those things inherently are new. So the Jamstack to me really is just a new way to combine old things. We're starting to get much more creative with the way we build web applications. And we start to use some of those existing technologies, not that there aren't new ones, but we use a lot of those existing things and just use them in a different way, which is kind of cool. And with the Jamstack comes a focus on static content. Now here again, we kind of lack a true definition of what static content is. If you were to poll everyone watching this video on what their definition is for static content, you would probably get lots of different answers. So our question becomes, what even is static? What does that mean in this case? Well, if you go to Wikipedia, they give you a definition. Wikipedia is the truth of all source, of course. And they say web page is one that's delivered to the browser as stored, in contrast to dynamic web pages, which we'll talk about more throughout the application, throughout the presentation, that are generated by a web application. So that's fine. A little simpler version here is one that I came up with. It's a set of files that can be hosted as is on a CDN, or a content delivery network. Now, a content delivery network is very beneficial because it can replicate those files all across the world and make it really quick and easy to get access to those files and send them back down to the browser. Now you're probably thinking like, oh, well, I don't know any CDN options that I could use. Well, you are in luck because Vercel is an awesome CDN that you can use for hosting your static sites, in addition to lots of other things that we'll talk about in this presentation. So the really cool thing about this is that you're not having to maintain a server. You're not having to do updates or patches or things like that. And that really gets into the benefits of the Jamstack. It's very performant. If you think about, there's no real-time calculation for this static content. It's just being sent down. That stuff is really fast to get to. High security, you're not maintaining a server. You're not doing patches. You're not doing updates. So you don't have to worry as much of that type of security, about that type of security. It's scalable, right? It's just files that are sitting there. Those can scale up infinitely when you get the big rush for people that are ordering Christmas presents from your site or whatever. And then probably my favorite piece is the developer experience. There's lots of different things that factor into that. So you might be wondering, talking about static content in the Jamstack, do static sites mean static experiences? And to answer that, I'll go back to our definition. Our definition is it's a set of files that can be hosted as is on a CDN. Well, the interesting thing about that is React actually falls into this category. If you're familiar with React, I imagine you are, You know that React has a build process. You do a build of your React app, and the output of that is a static set of files that can be hosted on the CDN. It in no way means that React applications or websites are static themselves in terms of experience. It just means that the output is a set of files. Now you get to Next.js. Next.js can do everything that React can, and then a lot of things on top of that, which means Next.js can do the exact same thing and produce what I consider to be static content. But we also know that Next.js takes it to the next level. This is something that we'll talk a lot about as we go through this presentation. So I want to get into the 3 different types of content that exist in the Jamstack. Now you may have a couple that you could debate or add in addition to these, but there's kind of 3 core examples of content inside of Jamstack. So first is CSR. This is client-side rendered content. You can have statically generated content coming from a static site generator, SSG. You can also have server-side rendered content. Abbreviation here is SSR, and then here's those definitions for you. So you also have like incremental static regeneration, and there's some other keywords and that kind of stuff in there. But this is kind of core to me, I think, in terms of the types of content that you have at your disposal in the Jamstack. So let's start with client-side rendered. So again, we go back to this concept of React. Now, Next.js can do everything that React can. It can act just like React if you use it that way. So we can just start with, like, if we're using client-side rendered applications, we can kind of think about the SPA idea, single page application, and we can focus on just React for now. And so these are just pages that are hosted in a CDN somewhere that are sent down to the browser, and then things happen. JavaScript runs and things happen. So the first question is, how do you do authentication and authorization with a single page application? Well, let's start with some fancy buzzwords. Let's just kind of see where we get there. Let's say OAuth 2.0. Let's say OpenID Connect. Let's say authorization code flow with proof key for code exchange, otherwise known as PXE. You're probably confused by those. You probably don't know the intimate details about those different things. And the important part here is you don't have to. Is it useful for you to have knowledge of what those things are and what those workflows are and how they work? Yeah, that'd be great. But this talk is targeted at people that want to build stuff. So the cool answer is, like, you don't quite have to know. One key thing to understand here, though, is that authentication in single page applications can be very different based on the fact that a single page app can't keep a secret. We'll talk much more about this as we go through the talk. In fact, it'll be kind of a theme in this talk. But this changes the requirements of how we do auth in the most secure way. That's where the PXE comes from, the proof key for code exchange. So you can go out and do some more research on that if you're interested. But that's one important factor about a single page app is it cannot keep a secret because that code is in the browser. It's public. API keys, secrets can be read by somebody if they want to. So here's a diagram that shows that flow, the authorization code flow with PXE. And the key thing here is that the output of this is an ID token and an access token. We'll talk a little bit more about those. In fact, we can now do a little bit of a comparison between the two at a very high level. ID tokens are mainly used for authentication. They contain general info about the user themselves. Access tokens are more for authorization, and typically what you'll do is send those to a backend API for validating authorization for getting to an actual resource, doing some sort of CRUD operation on a piece of data, that sort of thing. So we'll come back to that. More to come. But don't worry, it's not that bad. The cool thing is, this is what SDKs are for. There are tons of things that there are a lot of technical details behind the scenes that we as developers never know because we don't need to because of SDKs and tools that are out there to help us solve those problems. Now, again, if you're interested in OAuth 2, OpenID Connect, PXE, authorization code flow, go and do some extra research. It's actually really kind of interesting and neat, but you don't have to know that, especially for the context of this talk. So now I'll get into an example of our specific Auth0 React SDK. So implementing authentication, authorization inside of a React application using Auth0. There's the GitHub link if you want to check it out. But it's pretty cool. You can create an Auth0 provider with history. So this taps into whatever history, routing package you're using for React, like React Router. It taps into that. You can create that Auth0 provider with history. And then you wrap your application, and that's kind of most of the setup. After you have that set up, then you can go into your React code, and then you can just call a function. So we have this use Auth0 hook. if you use that hook, you can get from it the login with redirect function, and then you just have a button that says call this function. It redirects the user over to Auth0. They do their authentication. They come back to your application. And then how do you know if they're actually authenticated? Well, you can get another property from this use Auth0 hook, which is authenticated. And then based on is authenticated, you can show a logout button, a login button. You could show and hide different pages if you want to. You can also grab profile information for the user. So from the use Auth0 hook, you also get a user object. From the user object, you can get name, picture, email, things like that, and you can display profile information. So this is a pretty common thing, right? You need some sort of SDK or something you build to keep track of the user. And then you want to know, is the user logged in? If they are, what's the information about the user? How do I get access to that? What functions do I have to call for login, logout, etc.? In this case, this Auth0 SDK provides you a pretty cool hook here, the use Auth0 hook that gives you access to all those things. Then you just build your app accordingly. It's pretty neat. So my question then becomes, how do we get dynamic data? So we talked about like, this is a single page application. We talked a little bit about how you can do authentication, but where does data actually come from? Well, you fetch data from an API using JavaScript. You see what we did there based on the Jamstack JavaScript APIs. So that's how we want to get data, but where do we actually get that data? Well, you can use a traditional database. You can use a headless CMS. You can use a general API of some sort. And their goal, those services, is to make it as easy as possible for you to implement those services and store your data in their service. So you start looking at like SDKs for these things. Here's Trello and Cloudinary and Sanity. There's a bunch of different ones. And as you go through this documentation, you start looking at API keys and secret keys and app IDs and auth tokens. And you're like, I don't really know what to do with that. One caveat I should say here, the app ID is not necessarily secret. Those other three are. But primarily, there's some sort of secret credential that you have to use to interact with that data source, that API, that headless CMS. And unfortunately, the browser is not safe. Your source code is not safe. So you can't check API keys, secret keys, auth tokens into your source code that goes on GitHub. People can go and grab the token out of it. You also can't ship that token in code to the browser because there are developer ninjas out there just waiting for you to mess up and check that stuff in and go and grab your API keys and do whatever they want with them. Trust me, I've learned this the hard way. I have checked in a decent amount of API keys in my past, and it has been a huge hassle. So the takeaway here is to never reveal your secrets. And hint, this is actually going to be a pretty big theme of what we talk about for the rest of this talk. So something to keep in mind there. So naturally, your question is, okay, if I want data from these places, where do I actually get that data? What do I do? How do I get access to it? Well, I'm going to do a cop out here. I'm going to say, we'll revisit that in a few minutes. We'll come back to that. In the meantime, let's move on to our second style of content, is statically generated content that comes from static site generators. And lo and behold, this is Next.js Conf. Who knew Next.js can provide, basically act as a static site generator and give you static content. Now, I do want to clarify what a static site generator does in terms of acting or interacting with a data source and when. So let's compare really quickly. A static site generator or a tool like Next.js that can do static site generation, can generate static pages. And let's compare that with, lack of a better word, a dynamic site. Your WordPress, your Ruby on Rails, your Node backend with EJS templating, server-side rendered applications like that. So let's start with static site generation. You interact with a data source at build time. This means when you go and build your site, it's going to go out to the data source and say, hey, give me all the data like blog posts. That's the common example. Grab that information, generate pages based on it, and create those static pages. Now, because of that, this means that anytime you add new content to your data source, you're going to have to do a new build to see that new content on your website. Now, the benefits of this is kind of the Jamstacky stuff. It will be super fast. It will be secure because you're not running a server. You'll have great development experience because you can just kind of check in code, run a build command, and your site is live. And it's really easy to use. It's really pretty cool. A dynamic site, on the other hand, is real time. That means that it's going to interact with a data source as you make a request for a given web page. So you make a request to this page. The server says, I need some data for that. I go to the data source, grab the data, generate the markup, then send that down in real time to the user. Now, this means if there's extra data that's added to the database, you don't have to go through a build. It's going to now be reflected on the website. So that's one of the benefits here is there's no extra builds necessary. And this has been an established strategy for years. This is kind of the traditional way that we do web applications, or was at least for a long time. So static site generators in general are going to get data at build time and generate markup. You see what we did there too? JavaScript, APIs, markup, going back to the Jamstack. And the good thing about this, the interesting thing about this, the most important thing about this is this means that secret keys are okay. So since you're running this build process on a server, you can add environment variables into your host platform like Vercel, leverage those during the build process, generate that static content, never have to worry about getting those keys leaked by shipping them to the browser. It won't be in the browser, it's just running on the server, and then you've got static content. So that's cool. But let's go back to this question of how do we do authentication and authorization? Well, this answer with statically generated content actually becomes really easy, specifically with Next.js through a process called rehydration. And what rehydration is when you ship a piece of static content with Next.js, it's also going to ship React. And then on the front end, React can run just like it would in a regular single page application, just like it would in regular React. So this is really important for authentication and authorization because now you can do anything that you could before. You can treat everything almost the exact same, actually the exact same way as you did before because you're just running React on the front end just like you did before anyway. So that's kind of neat. And the question then becomes, okay, we still got the same question. How do we get dynamic data for this? What if we need to add, we have statically generated pages for blog posts, but now we want to dynamically pull in the comments? Well, we go back to this answer of, we're going to fetch data from an API using JavaScript, Jamstack. But don't forget, those developer ninjas are still out there waiting for you to check in environment variables or API keys to your source code. So we can't do that. We still have this gap of how do we interact with some sort of data source in a reasonable way. And this is where serverless functions come into play. Serverless functions now can run with minimal effort, really cool, and keep a secret. This is a constant theme in this talk is who can keep a secret. So you can run code in a serverless function, which, fun fact, runs on a server, which means you have access to environment variables and you can do all the things that you need to interact with your data source, whatever it is. Now, serverless functions are pretty awesome when done well because you just write a function and then magic happens. And you might be asking, like, where would I host these magical functions? Well, this is probably no spoiler alert here, but Vercel not only, or in addition to hosting your static content that we talked about earlier, can also serve your serverless functions or host your serverless functions. So the interesting thing about then like kind of moving logic to serverless functions for that API key is what stops people from just calling that serverless function directly. If that serverless function is out there, it's kind of just acting as a proxy. How do I actually protect that API route, that serverless function, depending on how you think of it? This is where access tokens come in. So we talked about, or we showed really quickly with the Auth0 SDK following OpenID Connect and OAuth 2, the output of that is the user will get, or the code will get an ID token and an access token. Access tokens be primarily used for authorization. So what we can do inside of this React world is from that use Auth0 hook, we get a function called get access token silently. We can grab the access token from a logged in user and then just send that in the request to a backend API. So it could be a serverless function. Well, actually, it would be a serverless function. It could be a different API on a different platform, but this could just as easily be an API route or serverless function hosted on Vercel. And inside of that request, we just attach that bearer token, or excuse me, that access token as a bearer token property for the authorization header. Now, I won't show you the backend code for this because that can be solved in multiple different ways, but on the backend, it's their responsibility to validate and then authorize access to certain things based on that access token that is being sent along. So this is how we can get away from not checking in secret keys to our front end, using serverless functions to kind of be that proxy, but also then protecting our serverless functions to make sure that only the appropriate person is able to call them and act upon them when they do. So this leads us to SSR, server-side rendering. And the really funny thing about this is Jamstack has come full circle. Jamstack had this really big focus on static content. That's kind of where this evolved. And then it kind of came to the conclusion of like, hey, like static content is great, but what if we need some server-side rendered content? What if we need some dynamic content? Well, that's where server-side rendering comes in play here. And no surprise, Next.js now can do that too, because Next.js can do it all. And frameworks like Next.js that can do it all, I'm kind of titling, I don't know if this is a thing or if I just made it up, titling hybrid Jamstack. These hybrid Jamstack frameworks can do it all. They can do CSR, they can do SSG, they can do SSR, and here's the acronyms spelled out again. So now the question becomes, how do we do authentication and authorization? Well, there's some things that change specifically in Next.js, because since you're running your serverless functions and your front end, and they're kind of on the same domain, you can now start to track things in cookies. And so now you'd have to learn about, like, how do I do these cookies? How do I still implement OAuth 2 and OpenID Connect on the back end to go and get the access token and ID token? And where do I store that information? And what type of cookie? Is it secure? Is it HTTP only? All those details. That sort of stuff comes into play now. And now you have this mix of, I need authentication for server-side rendered content. I need authentication for static content and all the different things that Next.js can do. Well, again, the Auth0 Next.js SDK is, I am biased, but is very, very sweet. I think in the most unbiased opinion I can have, this SDK is really fantastic. Now, there are other SDKs that have similar functionality, so don't think this is your only option, but this one is, in my mind, top notch. It's actually really, really good. So let's take a look at how you would set that up. Well, you think like, all right, you install the package and you do a bunch of things. Well, this is kind of it. You create a file in a certain location. It's a dynamic route handler. And what this does is, just by doing this and having your environment variable set inside of your .env file, is this will generate API routes for /login, /logout, /callback, and technically it's API auth, login, logout, callback, and then me for profile information. Which means those routes now are hosted or basically work as serverless functions, which now means I can just create a login button that's a link to /API/auth/login. Logout would be the same type thing, /logout. But this gets really cool next, because also there's still a use user hook on the front end that gives you access to the user is authenticated and things like that. So this use user hook now, not only can I handle like server-side authentication and tracking of that authenticated user, I also have hooks to work with that user on the front end and display some sort of information of, are they a login or are they an admin? If they are, show the admin button, show the admin link to get to the admin page. And then we get into even more functionality, which is, what if you want to protect your pages? What if you want to say, hey, if you're requesting to get access to this page, you need to be logged in. I don't want you to get access to this page if you're not logged in. Well, on the front end, we would have to do some checks, right? To say, hey, before we render this page, if we were in a single page app, check the status of the logged in user and do whatever checks we need. Now with get server side props and with this hook from Auth0 with page auth required, now we can just wrap our get server side props with this hook, and it will automatically make sure the user is logged in and not let them get to your page unless they are logged in. Pretty neat. And then you can do extra authorization stuff by checking properties of the user and that sort of stuff. But just with using with page auth required, it will protect those pages. Probably not a shocker here. There's also a with API auth required, which does the same thing for your API routes. So now you have the ability to make sure a user is logged in before they can access an API route. Then you can also do authorization based on some sort of claims or properties about that user. Are they an admin? Do they have other access, et cetera, et cetera. So that I think is really cool. And I want to end with a couple of integrations that I've done just with working with different data sources that I thought would be fun. One is Airtable. I used Airtable for a lot of automations and things that I do. I think Airtable is really great. It's very flexible. I use it for automated newsletter and sharing things out of my Discord with a Discord bot and lots of really cool stuff. So to integrate with Airtable, you need one of those API keys. We've talked about this kind of over and over again. And so the question becomes like, all right, where do you use your API key safely? Well, we've talked about serverless functions and how you can use your serverless function as a proxy. Like instead of calling Airtable directly, call the serverless function, which calls Airtable with the API key, but it uses that securely in an API route, which only runs on the server with Next.js. So you're using your serverless function as a proxy. And this is a very common pattern because you can do this for any API that you want to. Anything that you can't access directly from the front end, you can call a serverless function API route in Next.js, have that thing then call the API with that secret key, and you're kind of good to go. So that's really cool. And then there are some platforms, FaunaDB, or Fauna is one of them that I have worked with that has an even more direct integration. And there's a YouTube video on my YouTube channel if you want to check this out. Serverless authentication and authorization in minutes with Fauna and Auth0. And what this allows you to do is take that access token that comes from Auth0 and send that directly to Fauna, and you can configure Fauna to know how to validate that access token to make sure it came from the right place, and then leverage that, associate that with a role with rules inside of Fauna that define rules for CRUD operations on your data, which means I can actually do this directly from the front end, not really need a back end, and then interact with Fauna directly by sending that access token along. That is really, really cool. This is kind of almost what dreams are made of, honestly, to be able to do that stuff directly. So a little bit of configuration inside of Fauna. I can send my access tokens directly to Fauna. Fauna then knows how to interpret and validate those access tokens and then compare that with rules that are associated with a role inside of Fauna. Full video if you want to check that out. Now, the last one, Supabase, is a technology I've been pretty excited about. I think it's really, really neat. It's an open source alternative to Firebase. So this same concept, I think, will apply to Firebase as well. But when working with Supabase, what we found was Supabase does authentication itself. So Supabase can do authentication. What we found was the way it validates that authentication on the back end is through an access token as well. So we can kind of trick and take our access token from Auth0, grab the user ID from that access token, the sub property is actually what it's called, and then generate a new token with the signing secret that is inside of Supabase. Now, what this means is we now have a token that Supabase knows how to understand, and we can attach that to the Supabase client. This is something that's configured on the front end again, and then we can send that to Supabase, and inside of Supabase, you can define with policies your authorization, who's allowed to access what, based on that token that's coming in. That's really cool as well, because this means that you can do this, again, all from the front end, not even need a back end if you don't want or need it. Pretty cool. Jon Meyers is a developer advocate at Supabase as well. So you can go and check out, he's got role level security RLS with Supabase video on YouTube that I thought was really interesting in terms of defining those authorization rules inside of really what just comes down to SQL. There's a link to that one as well. So those are a couple of the different integrations that I think are really neat with other platforms that I thought you might be interested in as well. That is going to wrap up this talk. If you're interested in any more information or the slides, you can check it out at jamesqquick.com/talks. If you have any other questions for me, you can reach out to me in the Discord server. I will be hanging around in there to answer any questions that you have. So make sure to reach out. You can also reach out later on Twitter at jamesqquick or other places at jamesqquick.com. Thank you all for checking out the talk. I really appreciate it. I hope this was helpful. Let me know if you have any questions later on. Thanks for watching, and I'll catch you later.
Hey, I'm Allie, and I'm going to be talking about Fullstack Next.js on AWS. I lead developer advocacy for AWS Amplify. I am a Spittel on social media, and since I work on this product team, if you ever have feedback for me or feature requests, please reach out and I'll forward those on to the product folks. So our goals for this talk are to build something really, really fun. We'll discuss underlying services and we'll learn a little bit about AWS Amplify. It's a set of tools for front-end and mobile developers. We'll be talking specifically about Next.js in this talk. However, it also works for just like plain React if you wanted to do that, or iOS or React Native, any of those types of things it also works with. So there are a few things that I've noticed that most web apps have. So data persistence. So instead of just data being available to one user, multiple users, authentication and authorization so that people can sign in, but also so that they have the ability to have different roles and the ability to do different things. Plus, you need to have a front end. So enter AWS Amplify, which allows you to do all these things. If you go to sandbox.amplifyapp.com, you can follow along with me. So our first step is going to be to create our data. We're going to create a database using a visual interface. So if you went to that sandbox.amplifyapp.com, you can go to that homepage, you can click Get Started, then click Data and Blank Schema. then you can add some models. So maybe a blog, which may have some posts associated with it, and then we'll add some fields. So a blog would have a name and a post would have a title and content. Also, some fields may be required, like title. You can also change the data types of the different fields if you want. In this case, they're all strings. We're also going to add a relationship. So one blog would have many posts associated with them. So we're going to go ahead and add that relationship. Then you can test this out locally in your app. I know a lot of people don't have AWS accounts, and you have the ability to test this out locally on your machine without that AWS account if you would like. So let's talk about what's going on under the hood here. So data store allows you to have this online-offline programming model. It stores your data in Next.js, which is in-browser storage mechanism similar to session storage or local storage. This allows you to store more data and is also asynchronous, which is pretty helpful in a lot of apps as well. I said that you can test locally without an AWS account. If you do that, it's just going to have the data be offline until you deploy to the cloud. You don't need any extra code to have it sync to the cloud. Once you go ahead and deploy it, it'll automatically sync the data for you. AWS AppSync is a managed GraphQL API service. So under the hood, this is GraphQL that's being used. And Amazon DynamoDB, you gotta have something storing your data. And so it's a serverless key value document database that you can use to store your data. Under the hood, it's all under the hood though, so you don't need to use it manually or anything like that. It is there for you. So the next thing that we're gonna do is deploy this all to AWS. We're gonna put this out into the world. So again, if at any point you want to test locally, you can do so. You can also go back and change your models, repull to your friend, and then we're going to go ahead and deploy. So if you have an AWS account, you can sign into it or you can create a new one. So I'm going to log into my AWS account. I'll use my name and then my password. You can also set up your app name, so Amplify Auth, and your region. I just normally tell people to choose whichever one's closest to your users or yourself if you're the first person using it. Then you can update your backend. You can manage your app content in here. So for example, I'm creating seed data, and you can create 5 rows of randomized blog posts if you want. You could also use the form to create a post as well. So I'm now going to go over and create some seed blogs. I'll again do like 5 rows of that and then link to some posts because I want this relationship between the blogs and posts, so the blogs own posts. And I'll make them all related to this first one and go ahead and save. Also, this admin UI, you can give access to different people using just an email. So only one person needs to have an AWS account. The other people can either get full access so that they could change the data setup themselves, or you could give people limited access so that they can just read the content and change that, but they can't actually change the data modeling, which you might want to give a non-technical user, for example. So the next thing that we're going to do is add backend authentication. So inside this admin UI, I'm going to click configure login and sign up and enable authentication. And then I can add multi-factor authentication, different login mechanisms, and choose password protection settings if I want to make things more or less secure for whatever reason, and then deploy. It'll ask you to confirm deployment. Once it's done deploying, then there's a similar console that you can use in order to create users and groups if you want. You can also add authentication and authorization rules to your models. So I'm going to click on my blog and add an authorization rule here. So I don't want just anybody to be able to do full CRUD on a blog. Instead, I just want them to be able to read my blog. So I'll uncheck create, update, and delete. And then I need to make it so that somebody can create a blog. So what I'll go ahead and do is I'll create a new user group. So I'll create a group of admin users. So I'll title it admin, create that group, and then I'll make it so that my admins are the people that can perform full CRUD on my data. let's go over to the post now. So if I click on that post, then I can add different authorization rules for that. So again, I'm going to make it so that just anybody on the web can only view a post. And then I'm going to make it so that logged in users can create a new post. And in a lot of cases, you're going to want to make it so that only the person that created the post can edit it. So I'm going to enable owner-based authorization. But I want to uncheck read because I want more people to be able to view a post, but only some people to update and delete. Then save and deploy. And again, we're deployed. So now we have authentication and authorization for our application. The next thing that you're going to do is you're going to create your front end. So we'll do npx create next app in order to do so. So I'm in my demos directory where I keep all the things that I'm running over and over again for these talks. So npx create next app amplify auth. Once that finishes running, I'm going to change into the directory that I created, and then I will go ahead and install AWS Amplify's libraries, and then also the React UI component. So there's libraries for Vue, Angular, React, iOS, Android, all those. And so I'm installing the one specifically for React. I'm then going to pull down my app. So if I go to local setup instructions, I can click on my app ID to clone it down and then enable the authentication on the back end there as well. And then you can see a lot of code generation happen. So first the code generation from create next app, and then also for Amplify as well. So there's this backend directory. Inside of there is a GraphQL config file. There's also this AWS exports file. And that's going to have configuration information about your application. Once it's deployed, it's going to be fully populated with like your root to your API and things like that. But since if it's not deployed, it'll be an empty object. So I'm going to import Amplify and auth mode strategy type. So when I was enabling authorization, I had multiple types of authorization. So I had role-based with the admin groups. I had just whether somebody was signed in or not. And then I also had some other things as well. Oh, and this is the AWS exports file that I was talking about, by the way. And so I'm going to have to change a couple things in my app.js file so that my whole application has access to Amplify. So I'll do amplify.configure, and then I'll have my link to make it so that data store is able to handle multiple auth modes instead of just one, because I just enabled a bunch of different types of auth. So auth mode strategy type is auth mode strategy type dot multi-auth. What a mouthful. So now it's configured so that my front end is tied to my back end. What we're using for authentication is Amazon Cognito, which allows you to add sign-up, sign-in, access control, and multi-factor if you want, and social auth. So we're going to add that to the front end as well. We're going to use the UI components to implement this. So I've now updated that app.js. My whole app will have access to Amplify. So I'm going to create a sign-in.js file in order to create the sign-in form in there. So I'm going to create a sign-in function here. I'll export it. I'll add in a header and just say like hello. I'll also use the next link component and link back to my homepage. And I'll add a div because I'm gonna run into React issues of returning to elements. So I'll wipe out everything from my index.js and just link into that sign in component. So again, importing that link component from Next. Then I'm going to run my local server. And right now I just have this link to the sign-in page and then link to the home page. So not super interesting yet. But what I'll do is I'll import the with authenticator component from the React UI components from Amplify. And then I will wrap my export in that. It's a higher order React component. So now it's going to make it so that I have to sign in order to see the sign in page. You could also add this on your home component if you wanted it instead. So I'll create a username and my password there. I'm blocking out my password. And then in my email, I get a verification code, and you can change that email text. I just forgot password, but definitely update that. And then you're able to sign in. And if you sign out, then it'll ask you to sign out. And if you go back to that page, it would ask you to sign in. But we don't have logout yet. So the next step is to get the current user, and we'll use the amplified JavaScript libraries for that. So what we're going to do is now in this home component, make it so that you either conditionally see the sign in or the sign out buttons. So we have use state and use effect from React, and the use effect will run on the component being initialized. And so I'm gonna have this get user so that I can just have an asynchronous function in there. I'll add a try catch. Good practice for all your asynchronous calls. So then I'll import auth from AWS Amplify. And then in here, inside this use effect, I'm gonna have the await for the current authenticated user. And so this will grab whatever user is currently signed in, the current user session, and some information about that. So I'm gonna set that in state as well. So I'll set the user to be null by default or undefined, set my user to that user. If there's an error, I'll console error that error. You probably wanna implement a true conditional in that case. So I'm going to add a ternary operator in here. So if there's a user, then I want to have a sign out button, else I want to sign in. So I'll have the sign in as the else branch there. And then I'll have a button for sign out. On click, I want to actually have it so they can sign out. So I'll have an asynchronous function here. And I'll await auth.signout. So once they click on that button, it'll sign them out. And then I also want to set that user back to null. And you could do more complex conditionals based off of that too, like only show forms if they're signed in or signed out, and use those authorization rules that we used on the front end as well. So the next thing that we want to do is render all of our blogs on the page. So what we're gonna go ahead and do here is I'll import my blog, and from Amplify, I'm going to have to import with SSR context. So this is going to allow me to run Amplify code on the server side. I'll also do serialized model, and this will allow me to convert a JSON or convert an object into a JSON essentially. And then I'll import blog from source models. It was cogent in the pull step. So I'm gonna create a get server side props function, take my request, structure it, and then I'll use with SSR context in order to be able to run this on the server side. So blog data is gonna be my variable. I'll do another try catch block, always good practice. And then I'll set my blog data to the results of asynchronous server-side data store query. So data store, again, is what we're using for our data, and .query for blog is going to query to get all of the blogs, or all instances of that blog model that we created. So then I'll console error the error if there is one, and return the props object with the blogs, and I'll need to use that serialized model in order to turn that into a true object. So serialized model with my blog data. Now in here, I'll destructure my blogs and I'll map through them. So for each blog, I'll go ahead and return a header. I'll use the blog's ID as a key that's automatically populated. And I'll do the blog's name in the body there. Then if I save that, you can see that all my blogs showed up on the page. We're making progress. Our app is becoming more and more of an app. You now need to sign in and you can view all the blogs. So the next thing that you might want to do is create a new post. So what we're going to go ahead and do is implement this. So I'm going to, I don't like writing forms, so I'm going to use like window.prompt for all of this to make it really simple, but in real life you definitely want to create a form. So I'm going to import data store from AWS Amplify. I used AWS Amplify in the last portion of the demo, but I used it under SSR instead of using it directly. So I'm going to import it so that I can use it directly here. And then I'll use it on the client side instead of the server side. I'm also going to import my post model. Then I'll create a button. When you click that button, you're going to be able to create a post, and I'll implement a function that will fire on click. So let's implement that create post. It's an asynchronous function. Again, it's going to need to run code and no forms. So I'm going to do window.prompt title and then my content, which will be window.prompt with the content. And then I'm going to create a new post instance. So I will eventually save it to data store. So I will say that. And then inside of there, I will instantiate a new post. I'll provide to that post the title and content that I created right above. And then I will also add the blog ID. So normally you'd want the actual ID of whatever blog that post belongs to, but since I have the blogs already passed in as props, I'm just gonna use the first one from that array and then its ID from that. So our posts belong to blogs, so we need to provide that blog ID. So then what I'll do is I wanna query all of my posts. So I'm doing await data store.query with my post. And then I want to console log those posts. So you can see here, I'm going to create a new one. Hi and hello, very, very creative. And then if I look at my console, you'll see that my blog model has an owner. So back in our authorization rules, we set it up so that each post, certain behaviors are restricted to the owners. So you can only update a post if you are the owner of that. And so this owner field is populated here. And what you could do is you could create some logic so that the create form and the delete form only show up when the owner matches the current signed in user. You could also only have this form show up if a user is signed in, which you would need to have because of our backend authentication rules. So if you want to learn more, you can do so. We have full server-side render support for Next.js, and you can check out our docs at docs.amplify.aws. I'm a Spittel, again, everywhere, so if you have any feedback or questions, please reach out to me there. I'm also hiring, so if you want to work on as an engineer on this or a developer advocate, hit me up. Thank you so much.
Hello Next.js Conf. My name is Jon Meyers and I'm a developer advocate from Supabase. At Supabase, we love open source. We do what we can to support open source because we are open source. And so we wanted to take the time today to talk a little bit about what's under the hood with a Supabase project and highlight some of the awesome open source projects that actually make that possible. Koppel is going to take us through Postgres. That's a REST API layer that sits on top of a Postgres database, and is going to cover auth in Supabase using Netlify's GoTrue library. Wembo takes us through how Supabase implements real-time using Elixir and WebSockets. Inian is going to explain how Kong is used as a gateway and a little bit about file storage. Johnny is going to take us through some of the UI tools that make up the dashboard. And finally, we want to showcase an awesome community project called Slip, which is a course marketing platform built with Next.js and Supabase. Over to you, Koppel.
Hey everyone, I'm Koppel, CEO at Supabase. Today I'm talking about one of my favorite open source projects, Postgres. That's Postgres with a T, not PostgreSQL the database. Postgres provides an auto-generated API on top of your PostgreSQL database. And instead of explaining why I love Postgres so much, I thought I'd show you with a demo. I've started a Postgres database using Supabase. I'm building a Slack clone, so I've added some tables which you're probably familiar with. A messages table which stores all the user messages, and a channels table with the default public and random channels already populated. For this demo, I'm also adding a new table called leaderboard where I can store both the user ID and the total number of messages each user has sent. Now let's jump into the auto-generated documentation for our demo. As you can see, the docs are populated with all the tables we just created, including the leaderboard which we created live in this demo. The API is extremely powerful. You can use it to fetch individual columns or all the columns. You can add filters to only return a subset of rows, and you can even build nested queries just like GraphQL. Let's jump into the channels documentation and copy one of the requests to see how it works. First, I'm going to select everything in the channels table. I can use the JavaScript libraries, but for this demo, I'm going to make the request directly using curl, and I'm going to use an anonymous user. After I've copied the code, I can run the request, and it will return both the public and the random channels. Now let's modify the request to return the messages as well. Postgres automatically detects a relationship between these tables, so when I run the query again, I now receive the messages in each channel. Postgres is an extremely thin layer on top of PostgreSQL, which means we can use many of the features of PostgreSQL inside the API. For example, our API doesn't seem very secure right now since it's returning all the messages for our anonymous users. Let's change that by turning on PostgreSQL row-level security for our messages table. After we've done that, we can run our query again, and voila, the API is no longer returning data for our anonymous users. In this demo, I just scratched the surface of what Postgres can do. Postgres is a connectionless API, so you can use it with any Jamstack or serverless framework, including, of course, Next.js and Vercel.
Hi, I'm Ant, co-founder and CTO at Supabase. Supabase Auth is two things. First, it's an authentication API, which you can use to sign up your users using their email, mobile phone, or one of a long list of OAuth providers, such as Google, Twitter, Apple, or Discord. Unlike other auth providers, the user data is stored inside your database, so you have full control over it at all times, which is great for privacy and awesome for things like GDPR compliance. Logging someone into Supabase is as simple as supabase.auth.signin and then pass the email and password directly from the client. And account recovery for forgotten passwords is all included. Supabase even manages the transactional emails, which of course are also fully customizable. The second thing that Supabase Auth is an authorization layer. You can write access policies in plain old SQL, instructing your backend which data a given user should or should not be able to access. And because it's just SQL, your rules can be as simple or as complex as you like. You can implement admin or moderator accounts using role-based access control, or you can do more advanced things like limit the delete access according to the time of day, or geolocation, or whether the user has a certain email domain or mobile country code prefix. Another cool thing made possible by our auth and file storage integration is that because we store the entire object tree in your database, you can write these row-level policies to control access to all of your folders, files, and buckets. If you want a bucket that's available to the public and another storage bucket that's only available to pro users, you can do that, and it's easy. And you can do it all from the Supabase dashboard. As with everything we do, Supabase Auth is also fully open source. So if you want to add some new functionality, let's say a new OAuth provider, or just audit the code yourself, then it's all available on GitHub. I hope you have fun playing with Supabase Auth.
Hi, I'm Wembo, and I'm a software engineer at Supabase. Supabase Realtime consists of a server and client working together to send Postgres database changes to users in real time. Realtime server connects to the database and subscribes to insert, update, and delete changes via Postgres logical replication and broadcasts those changes via WebSockets. We decided to build the server with the Elixir programming language and Phoenix web framework for a number of reasons. We chose Elixir because it enables massive concurrency, fault tolerance, and isolation by utilizing the Erlang virtual machine, which has been battle tested over its 30-year existence. We chose Phoenix because it takes advantage of the best of Elixir while providing the right abstractions, such as channels, making it easier to work with WebSockets ranging from thousands to millions of connections. All of these features were important to us for the type of highly available and performant real-time server we wanted to offer to developers. And as we continue to scale the real-time server, it gives us peace of mind knowing that apps such as Discord and WhatsApp rely on Elixir and Erlang respectively for their chat infrastructure. Real-time Client establishes a WebSocket connection, enabling communication with the real-time server, and receives database changes. Today, there are official Supabase clients, as well as community-maintained ones written in JavaScript, Python, Dart, and C#. I want to quickly demonstrate Supabase Real-Time in our Next.js Slack clone that's available on our GitHub. Here are two users, Wembo1 and Wembo2, who are sending messages to each other. Messages are inserted into the database via PostgREST API. Then Supabase Real-Time will pick up the inserted messages and broadcast them to both users in this channel. Now let's go ahead and take a look at the messages table using the Supabase dashboard. And as we can see, all the messages are present. Next, let's use this dashboard GUI in order to insert a message into the messages table. We can see that the message was broadcast to both users. Finally, let's go ahead and insert a batch of messages in a single database transaction. In this case, there are 4 inserts inside of the transaction. Again, both users will broadcast the messages inside of the transaction. Now, it doesn't matter how you get data into your database, but once it's there, Real-Time Server will pick up the changes and broadcast them. We're currently working on improving the security of Supabase Real-Time by only broadcasting changes to those users who are authorized to receive them according to Postgres row-level security. We'll be releasing this into production very soon. We're also working on providing additional real-time functionality to developers who are interested in building synchronous apps. Thank you, and I hope you have a great time exploring Supabase Real-Time.
Hi everyone, I'm Inian from the Supabase team. We use Kong for our open source API gateway. Kong is built on top of Nginx, which is very battle tested and powers a large portion of the internet. And Kong offers a lot more features on top of it, which makes it ideal to use as an API gateway. All our other services like storage, Postgres, auth are protected by Kong. Apart from authorization and routing, one of the key features that we use Kong for is SSL termination. We use Let's Encrypt to provision our SSL certificates for all projects hosted on Supabase. Let's Encrypt is open source, builds on the Acme protocol, and has provision certificates to more than 260 million websites. Kong is flexible with support for a lot of plugins, and in the future, this would help us implement rate limiting, adding and removing API keys, and Kong has a good foundation for implementing these features. Supabase Storage is an object storage service. You can upload any asset or media file to our service. Storage integrates very well with the rest of the Supabase ecosystem. Storage sits behind Kong, and the metadata for all objects is stored in your own Postgres database. This makes your data very portable, and since we target the S3 API, it makes it very simple to add support for most storage backends like Backblaze, AliCloud, and even the Cloudflare's newly launched R2 service. The storage API is built on the Fastify framework. It is one of the fastest web frameworks out there and has a very rich ecosystem around it. Our client library for storage, Storage.js, has a very familiar API. If you have used our client library for Postgres, it follows a very similar syntax to that. We have a profile management example which makes use of storage, and you can deploy quickly to Vercel. That should get you started with Supabase Storage, and excited to see what you build with us.
Hi everyone, my name's Johnny. I'm from the Supabase team, and I'd love to talk to you about our dashboard. So our dashboard, for anyone who's familiar with Supabase, you'll know how it looks and how it feels, but you probably have no idea what it's built with. And it's probably no surprise to anyone. We use Next.js. We use Next.js for pretty much all of our websites. We use Vercel as well. So all of our serverless functions are on there. We also use SWR. Also interested in using multi-zones, which we haven't implemented yet, but we're interested in putting all of our Next.js apps together so we can have we can put them on their own URL, I suppose. So like our documentation site could live on /docs, and our dashboard can live on /dashboard, things like that. But what do we use that isn't Vercel based? Like what other open source stuff do we like? So one of them is MobX. MobX we use for state management. I think usually you use one store, like one main store. But we actually use several. So we actually have a MobX store for kind of everything. So we try and replicate what we have remotely, locally. To give an example, if we were using Supabase Postgres meta, we would fetch tables from it, which would be the metadata for tables for your Postgres database. We bring it down, and then we would actually save it in a MobX store called tables. And that would be accessible anywhere in our application, along with other stuff like maybe tables, projects, schema, and we can list them all, get the length of them, or whatever we want. It can be done anywhere in the app. It's pretty handy. Another thing that we're quite interested in doing is dog fooding our own Supabase real time. So if there's any changes, so for instance, someone adds a new table, that would come down Supabase real time. And then we could add that change into the MobX store automatically. And then all of a sudden your client is already up to date with the change that's happened remotely. Really cool stuff. Moving on, our UI components. So we can't talk about the dashboard without talking about visually how we put it together. So we're using Radix. Anyone who's been working on front end would have probably heard of it. It's an accessibility focused design system. It means that kind of the components in it, or primitives as they call it, handle all of the kind of accessibility needs for you. So things like keyboard control, Arial labels, it's all done for you. And all you have to do then is style it, or like structure it the way that you want, add the CSS you want, and then you have fully functional components that look the way that you want. But the way that we style it is, it was actually a singular CSS file for each component. But we're actually moving towards using Tailwind, because we use Tailwind everywhere. Everyone in the Supabase team loves using Tailwind. So like, why did we stop using it for the UI library? So we're actually working on a theme provider that kind of wraps around the whole app, and then it would inject the correct Tailwind CSS classes for each component. And you can see here, this is my example of changing the Supabase brand to purple, which I don't think anyone is gonna like at all, but I can keep showing people, and maybe one day Supabase will be a purple brand. For forms, we actually had several different implementations of forms, but one library that we've kind of decided on because it was just easy to use, it was stable and just easy to use. We just liked it. React hook form. So we're kind of like rewriting some of our UI components so it works well with React form. So that's pretty cool. And the reason we've actually been working on the React form stuff in the last week or so is actually because we're really trying to open source our dashboard. So everything that you saw before at the beginning, we're going to make that publicly accessible. And it's probably going to live in this repo called Supabase. There will be like a directory called Studio. And we're going to put the dashboard in there. We're going to try and open source as much code as possible. We're working flat out to really pull apart our code. So anything that's kind of infrastructure based, that's to do with billing or to do with our actual like hosting platform, we're trying to like separate. It's been a bit of a big job. We know people have been asking for it, but hopefully soon it will be open sourced. But you heard it here first. Yeah, we're open sourcing it. So thanks for listening, and on to the next speaker. Thanks.
Hey everybody, I'm Kenneth and I'm the founder of Slip. We're a marketplace that makes it easy for expert developers to build and sell interactive programming courses. We were in the most recent summer 2021 YC batch, and we're big fans of Next.js and Supabase. Both of these tools allow us to iterate super fast on our product, and I think they're really amazing tools that help a small team like ours get a lot done really fast. And today I kind of want to tell you specifically how we use these tools and how they help us at Slip. I think a great place to start is kind of the evolution of our tech stack. So initially, I started building Slip when I still had a day job, and I had never used Next.js. I was building it using a Create React app kind of scaffolding, and then I had a traditional front-end, back-end kind of architecture where the front-end was React, the back-end was a fast API server. It's like a Python API server. It's similar to Node. And then I had a hosted Postgres database. The stack worked okay. The main issue I had with that stack was that I felt it was extremely slow to make schema changes to my database. When I made schema changes to my database, there was a lot of kind of boilerplate code that I had to write inside of Fast API. Fast API is a great product and it has a lot of cool like auto-generated stuff for you, but it still felt quite slow to add like new tables to my database and interact with it. So the first thing I did was I switched to using Next.js and I got rid of Fast API. By using Next.js, I was able to move all those calls to the database into the API layer inside of Next.js. So this really sped things up. It made things a lot faster as far as like development speed. And when you're a startup that's pre-product market fit, like being able to iterate fast is like one of the biggest things that you can focus on. And so we really kind of focus a lot at Slip about choosing tools that help us iterate as fast as possible and get a lot done. So we switched to Next.js, and that also had the added benefit of kind of like cleaning up the structure of my code and making it like a standard pattern that anyone coming off of the street and working on the project could really easily kind of get their feet wet if they've used Next.js before in the past. So that was actually like a hidden benefit that I didn't think about, but it's been like really great so far. So, as we've had contractors and like employees come on to Slip and work with us, having Next.js and like that standard pattern has actually been really great in getting people up to speed on the code. The next reason why we ended up adding Supabase was initially because I just wanted a better UI for interacting with my database. So if you've ever used like PG admin or other tools like that, it's really not the best experience. It's like pretty buggy, it's slow, it's unintuitive, and I just thought that the Supabase UI for interacting with your actual database was really nice. And so there's lots of times where we want to go into the database and like get particular information out, and it's just easier to use the UI. And that was the initial reason why we switched to Supabase, was because we just wanted a nicer UI for our actual interacting with our data. The surprising thing was that we ended up finding out Supabase was so much more than just a better hosted Postgres, and it's actually allowed us to ship even faster. So now like we're pretty proficient like Supabase users. We really love the project, and we use multiple things from Supabase to build faster on Slip. So not only do we use the hosted database, but we also use storage and authentication. And with that, it makes it super easy to actually write client-side code to retrieve data, and you can restrict it to users based on row-level policies, which is really awesome. And I think basically with the combination of both of these tools with Supabase and Next.js, like we're able to like ship and iterate on new features like at a pace that would have seemed like crazy to me a year ago. I think that, when you're a startup, choosing tools that help you ship faster is a really great way to make sure that you are, interacting with your users and you're building the right things, and that you're just kind of like continually like getting that feedback loop. And, Supabase and Next.js really help us do that at Slip. And that's me. I'm Kenneth, and I'm the founder of Slip. And, hope you guys enjoy the rest of the talk. we're big fans of Supabase, big fans of Next.js, and encourage you guys to check both of those tools out if you want to ship faster.
Thanks, Kenneth. It is super cool to see Next.js and Supabase working so well together. These tools go hand in hand, both built on open source, both cater to the client and the server, both helping to build a better, faster web. And we are very excited to see where people take this in the future. Thanks for your time, and go build some cool stuff.
Hi there, I'm Dan. I'm an investor at Excel, and I'm lucky enough to be on the boards of Sentry and Vercel. So I'm thrilled to be at NextConf with David Cramer, the founder and CTO at Sentry. And we're going to do a little walk down memory lane. But first, I'll let David introduce himself maybe a little bit.
I'm exactly what Dan said, a founder and CTO at Sentry, which mostly means I once wrote a lot of code. And I play administrative assistant mostly, but have lots of strong opinions. So
I too once wrote code, and now we're both useless. But we're also getting old. I always joke about this. You know, it's obvious with me. I look old and I'm bald. But David's old thing is he's now becoming an amateur astronomer. So plug for Noe Valley Astronomer on Instagram. You guys should all check it out and just make fun of David ceaselessly about it, which is great. Well, anyways, what I want to do during this is we're going to talk about Next in the context of delivering great end user experience and great developer ergonomics. But we're going to do it by comparing it to like when we showed up in the industry and what it looked like. So we're going to do a little walk down memory lane, and then we'll talk a little about the current state of affairs that's getting better every day, and maybe some of the things we need going forward. Okay, take me back. I'm David Cramer. It's the early 2000s. Where am I? I'm in Kansas, and I'm building web apps. What does the tech stack look like for a developer building web apps then?
it's close, Nebraska, but
Nebraska. It's the same.
I mean, I'm a self-taught engineer, so it means I still today don't know what I'm doing, and so this is probably wrong. But I remember early on, I would open up, some kind of editor, probably on a server, probably through an FTP connection, and I would copy index.php into index2.php, and I'd make my changes there, and I'd see if the website still loaded. And usually it didn't for the first 10 times. And so then you just keep going until it compiles and you've got a new feature. But mostly it was accessible. I just had to log into the server and, it's deployed instantly.
Totally. I remember when I was first getting into this, I had a Mac, and I downloaded MAMP, which was the Mac version of the LAMP stack, and I could just start editing index.php and then saving, and I would see like a local server version, and it would work, and it was awesome because it was super, super easy. And then my first web job, we worked on a product doing it, and we were a small team, and it was incredible. You'd FTP things, no version control whatsoever.
Yeah.
And it was kind of the glory days. And the cool thing was, as a developer, you were just like text editing. I mean, maybe using an editor like Eclipse or was back in the, I don't know, there was weird things back in the day.
Text.
BlueJ for Java. There was weird stuff.
Edit plus or text edit plus.
Eventually TextMate, but that was later.
TextMate was later.
So it was really cool. And then the problems came up. So this is the early 2000s, and some of the biggest websites in the world get built in PHP. So first there's like Yahoo in the late 90s, and then Facebook and Etsy and things like that. But you get bigger, and you run into some problems with PHP. So like, what are some of the challenges of that? So maybe it's easy to get started as a developer, but what are some of the roadblocks you would hit as a developer, and also maybe as delivering the experience for end users?
Yeah, I think a lot of it is just like kind of how the scope of tech has evolved. So index.php, all your code's in one file. Maybe you included some other files, but you're basically building a framework at that point. And so I think what actually happened is PHP was kind of fine. Maybe it had some problems, but it was kind of fine. It's still in use today, like big frameworks, right? But it was more we didn't have fast ways to get the actual thing we wanted to do done. So like, I remember, so I started Django 0.95 or something a few years after I learned to write terrible PHP. And the delta was I could create basically an HTML page and drop in a little widget that had comments. And it wasn't like a third-party service. It was just a locally, fully encapsulated, rendered comments widget. And Rails had the same kind of thing. And so all of a sudden it was, instead of building like endless boilerplate code, like, okay, they abstracted a bunch of things for you.
Right. And
I think that had to happen just because like the scope of the internet was bigger. There were more kinds of things going on, like more kinds of products, more depth to the products, I guess. And so I think, and I'm sure bigger companies had some of this even back in our terrible PHP days. But that was the big delta for me. It was just like technology became more complex because it was trying to do more things.
Yeah, organizations were getting bigger, and PHP, with the freedom of it, was you could do whatever you like. And the downside is like you were, the joke was always it was just spaghetti code. You were kind of tying things together and stapling stuff together. And all of a sudden, the mid-2000s roll around. And this is, to me, at least the era of Django and Rails probably was prominent. I was a Rails developer briefly at Crunchbase. And you had this new thing. So with PHP, you basically downloaded LAMP from AMP and you just got running. And in Rails and Django, you basically started to develop like this like concept of norms, and like a build step kind of concept showed up. Heroku became a thing with build packs. And so now, as you alluded to, you could build bigger projects. And you worked on Django closely. That's actually the origins of Sentry. Was as a tool for Django. And so the upsides here, you get this developer productivity, organization scale a little bit better. But what were some of the downsides of that approach from a developer experience perspective and maybe a user experience?
Yeah, I think you kind of nailed it with just Heroku. Like Heroku had to exist. It's like that's the inevitable outcome. Like you had to have some kind of, if not a build process, you had to have some way to get the code into production to run it in a different kind of environment. Because like PHP, the file just executes in real time, kind of compiles on the fly or caches on the fly. Python doesn't do that. Rails doesn't do that. And so you had an intermediate server all of a sudden, which meant you added on all this other complexity, I guess. And Heroku build packs, or Heroku in general, I don't know if it was the first. I actually don't think it was the first. But it was certainly the most popular way to not have those problems. Because I just remember all of a sudden it's like, you go from I just have to put the files in the right place on the server for them to execute to I actually have to configure a server entirely, right? Like it's wildly different outcome, I guess.
Yeah, and all these things develop around that. So this is the era of like Git to deploy, and more Git stuff. GitHub shows up around this time, which kind of seminal stuff. We're using more open source. I remember, PHP when I was using it didn't really have like a package management tool of note. I mean, eventually I think Composer, right? And Python, this was like a big war early on, which
is a big war.
Is still a big war about that. And there was like virtual environments for Python. I remember coming from the PHP world, I was like, what is going on? It's like really hard to get started. But then you would get into it and it got easier. Like it just made more sense. You could iterate a lot faster as a developer. You could take advantage of all these great tools, but you had downsides. But you were building large, complex web apps, which was really exciting. And then all of a sudden, and by the way, this actually we should note, this is like what spawned Sentry, which I think is a great story. So all this is going on. Django exists is getting popular. Heroku shows up and is getting popular. At the time, there are these old school error logging tools that exist primarily in the Ruby ecosystem. You build Sentry in the Python and Django ecosystem originally, and people from Heroku show up and say, would you like to be in our marketplace? And you say, sure. And then they're like, okay, you have to run a service, right? You had to offer a service and be accessible via an API. And that's the birth of, Sentry as a service in kind of a really cool way.
Yeah. Got tricked on that one.
Yeah, a little bit of a bait and switch. And I remember the days of the Heroku marketplace. That's a thing. But at the same time as this is going on, and this is like a seminal moment for everyone in tech, in 2007, right, the iPhone comes out or something. In 2008, the App Store comes out. And all of a sudden, people start building mobile apps.
Yep.
And the way I always thought about mobile apps was you're building the app that sits on the phone first, and the services are kind of in service of that, right? All the third-party stuff. And that's exemplified by the approach like a Parse would take, where, you're an iOS developer, you don't know much about backend servers. We kind of, give you a version of that. But I think one of the key moments about it was, in the earliest days of the web, I remember this like seminally, like you would navigate and a whole page refreshes.
Yeah.
And I think technically Internet Explorer gets credit. 99 Ajax comes out. And then the first app we all probably experienced using it was Gmail in 2004 and Google Calendar. And they're these great apps. But now the iPhone comes out and every consumer wants that. Every consumer sits there and says, I want an interactive app. And they're like, well, we got to build this thing. But the web then wasn't, I remember, and actually I should give a shout out to Guillermo for this from Vercel. So then, I remember in the mid-2000s, you were using jQuery. I think it came out 2006, 2007, John Ressig. And there was MooTools, which is why I'm giving the shout out to Guillermo, which was the other thing besides jQuery. And that was, I think, Guillermo's first big purview into open source was being a MooTools core contributor. But they weren't really made to create great experiences. They were kind of like delightful little front-end ties. And so now people said, how do we create iOS-like experiences, end-user great on the web? And at the same time, React comes out from Facebook. And there's other approaches. There's Angular. There's other things that do a flavor of this. And there's Objective-J and Cappuccino for the JavaScript nerds out there. which I'm a huge fan of. And so this stuff comes out, but it's hard to use. It's a totally new paradigm. All of a sudden now you have front end, you have back end, you have builds, you have weird flows. Like front end engineers hadn't historically been the kinds of engineers who would use a system like React. Pete Hunt famously mocks them accidentally for a while on stage. They get very mad at him. Sorry, Pete. And that gets us into the mid 2000s in the world of what eventually became Next. React is hard to use. Next, much like maybe Flask and Python, is like, it's a simple way to get started. Building on React, building rich front ends. It's the first thing that's like, okay, you can build a mobile web-like thing, but now all the services, dev tool, dev experience is broken again with React. Now we're in the world of JavaScript bundlers and stuff, right? So, okay, so take me through, and this actually, now Sentry, the company, comes into play, because I remember when Sentry made a huge bet on JavaScript, both internally building our tool, and we loaded an obnoxious amount of JavaScript. We have a great loading screen for that. But also with kind of our SDK support we focus on. So take me to like what you thought about developer experience and user experience in kind of those early 2000s, mid 2000s.
Yeah.
The beginning of Next, but maybe
so I think there's some like misnomers. So I think the mobile thing, mobile's always been like a bolt-on. Like everybody bet on it back in the day, but it's still like a bolt-on. Like nobody actually cares about mobile as like a core business product. Yes, everybody invests in it, but it's not like Walmart.com is just as important as the Walmart app, right? Like it's basically just how do we put Walmart.com into the mobile app. That's actually what's become reality, right? And I think obviously the interactive experiences were important, but I think the gap along the way is like engineering. We like to, over-engineer is the simplest way to put it. We like to like, oh, there's a cool idea and let's take it to the extreme, which is always bad. So we're still in the extreme version of JavaScript is going to be my analogy. Dependencies were a problem. So NPM comes along, makes dependencies easy. Now we have thousands of dependencies. I run NPM install, my machine lights on fire. So we like to take it to the extreme.
The famous left pad.
Yeah. Yeah, lots of problems with it. So I think, so we're still immature in that regard. But I think the interesting thing is some of the technology's changed. So even how like Vercel works, a lot of it is just like caching. It's CDN. It's not like new ideas. It's done slightly differently, but it's like old style ideas that have existed for decades, right? It's like, how do we make the experience fast and pleasant for customers? And generally you do that by bringing the customers closer to the code.
Yeah.
Now the problem with bringing the customers close to the code is bandwidth and latency are not a solved problem in the world. Like, seems great here in San Francisco. We got fiber in our apartment buildings and everything, but like, I don't know, you go to rural Africa or India or something and it's like, good luck loading half of our web applications.
I still remember we worked at Dropbox together, and I remember when we did a big partnership with Samsung, which is in South Korea. And so we're in South Korea, and somebody loads Dropbox, and it takes forever. And we were all shocked by this. We were like, "What?" And it was a painful moment.
It's that bias that everybody forgets about. And so, like in Sentry, we're guilty of this. Our bundle size is probably a few megs, and that's why we show this obnoxious loading indicator because we're like,
which I love, by the way.
We're just honest about our failures, right? And so I think Next is interesting, and I think there's a long ways to go for this kind of technology, but it's interesting because it tries to change the compromise, I guess, a little bit. So the way I do the analogy, so Sentry, we always talk about, Sentry's purpose is not to prevent bugs. You can't prevent software bugs. But the whole purpose of like sort of software toolchain is to accelerate software. It's basically how do we ship more code and ideally break less things and just do that as fast as possible. And so Sentry kind of plays that balance. And I think Next is kind of doing that a little bit in the sense of like, we want those fast user experiences, but we don't want to download 10 megs of JavaScript just to have it, which, you know, for some cases, maybe that's okay. But for many, that's too much. And I think it's interesting, but I think there's still a lot of unsolved problems in the industry. Like my classic example, and actually even Sentry's perfect analogy of this is like, you ship a bunch of JavaScript code, something goes wrong, you don't have logs. Okay, so we build Sentry to solve that problem. You don't have metrics. You don't have any of these other tooling like paradigms that exist for server-based code, or even to some degree mobile apps, but they don't have any of this either, right? And we're doing performance monitoring now. You don't actually have performance monitoring for JavaScript. And more so, what is performance monitoring?
Yeah.
What is performance? And so we have web vitals, and who knows if they're useful. And there's all these things going on. And so I think it's on a rapid state of change, and it's been that way for a good 5 years now, I would say. And it's probably another 5 years till we figure some things out, I would say.
Oh, I think it'll keep changing. I mean, I like in this, like, so we were really old doing that PHP stuff. Then I remember the first time I used Subversion. And one of the downsides of Subversion as a version control system for those folks who haven't had the joy of using it is it created like a blocker. You had this huge challenge of like you had to like get your pull request or whatever accepted, and somebody would own the Subversion and tell you no, this, no, that, whatever. And we moved to a world of Git where it became a little more distributed. commits became more atomic. So I could do smaller and smaller pushes or kind of pull requests. I could accomplish a lot. But of course, that created its own, world, which I think of as like the GitHub marketplace, where it's like every pull refresh now has like 15 badges of something going on. There's like a linting thing, and your code coverage, and you're running your tests, and you're doing all these things. But no one wants that. I don't mean that in a negative way, but like nobody really wants those things. What any developer wants is like, I want to just push something as quickly as I can in the smallest way possible to production.
Yeah.
And sometimes I want that to be to an end user. But even if I want to just do like internal testing or show it to a colleague, I just want a real URL that's running in prod.
Yeah.
And so, in the mid 2000s, when you have that Rails Django stuff, like testing became a huge deal. Like things like Circle CI grow up. But the reason Sentry exists is you're not going to catch everything testing pre-prod. It's just going to happen. You need great monitoring in production. You have no choice. And now Next and Vercel really move things in a great way towards now it's easy to get a deploy URL. So now it's not just easy to have a pull request. You have an easy deploy URL, which is awesome because as a developer, you can push more and more stuff faster and faster, and it's live. It's like real. Now you can show it to your team, and then you can show it externally. But the problem is, just like we need to do a lot of stuff on tests and whatever it is and testing in prod, now you have way more effectively releases. You have way more code out there. You're showing some stuff internally, some stuff to a canary set of users, some just everyone. And you need monitoring systems that work for that, right? And not just monitoring systems, by the way, like A/B testing is now trivial. It used to be much more complicated how you're setting up an A/B test, and it's not clear everyone needs them all the time. But yeah, it'd be nice if you could just, instead of just having a branch, you have literally a deployed URL where you can test, you can do A/B testing, you can optimize page, you can do personalization. But as all this happens, your complexity grows, and you need guardrails. You need to know like what's going on with that system, and that's where things like Sentry come in, which is it's great that we can do more stuff faster. That's the right move for a developer. It makes a developer's life better. But that developer also wants to know like, how's it going? How does that affect my users now that I'm pushing? I remember like in the early 2010s, everyone was like talking about, people were bragging about how many deploys they would do a day. It was like a whole thing. And that continues to spike massively. But the more and more deploys you do to different segments, the more you need telemetry, monitoring to understand what's going on.
I think it's just the cycle of technology.
Yeah.
And take microservices. Nobody talks about them anymore because it's broken. You can argue with me, but it's a broken model.
Sure.
And it's not any different than service architectures. Now, analogy to today is like, cool, we have some of these awesome developer workflows. We can ship this front-end code really fast. It's a distributed system. Nobody knows how it works. And so I think there's this interesting, and it's the same as like the monitoring or the testing or anything. We kind of solve a problem, or we push the boundaries and we break everything along the way, and you got to go back and fix everything. And so I think the interesting things for me are less about like, can we do A/B testing more easily or anything? Because it's something I've never cared about. But I actually think the idea that we can safely test is more interesting. Because I've always been like, when I overlapped with Dan at Dropbox, I was working on dev tooling or dev infrastructure. And so a lot of my investment was CI and CD. I didn't own the CD part, but it was really about like, is the code stable? Can it be deployed quickly? That's always been my goal as a developer. And the interesting challenge was always like, can you make the CI environment at least test that it's going to work in production?
Yep.
Your dev env is never going to be production. You just can't solve that problem. But can you do that? And there's an interesting idea, and this is kind of Sentry's thesis, is if you can monitor the code, ignore the systems, because systems don't matter. Like, you can't control Vercel servers or anything, right? You can't control the CDN, the devices that code's running on. So ignore the servers. You control the code. So if something goes wrong, you got to be able to change the code. So that's kind of our premise with Sentry. And then the interesting aspect of how the world's changing is something like Vercel, you can deploy two versions side by side very seamlessly. It's roughly the same architecture. You don't have to build any of that scaffolding. You can do it with Heroku and stuff like that, of course, too. But it's like more people are invested in this model now. So you deploy version A and version B, Sentry can monitor both and tell you if version A and version B are like, are they different? Is one better? Is one worse? Like, did you create new bugs? Are more things slow? All this stuff. And it's not like a groundbreaking idea, but the technology's finally getting there where, blue-green builds and stuff like this are becoming much more mainstream. Whereas like 10 years ago, this was like a great idea that we could not execute on.
Yeah,
at least not well.
People have talked about test in production for a long time as a concept, but it was just harder to do because there was always like a little bit of a gap between staging dev and prod. Yeah. And with a thing like Vercel, you get better and closer to that. You get closer to like, hey, these are basically the same as provided Vercel is doing everything the same. And now we can really do that easily. So it's great for developer. Okay, so now we've talked about where we are today, but you mentioned JavaScript in the world of web technology, and web app technology always changes. I always think as like a former app developer once upon a time, what I want is I kind of just want everyone to get out of my way and let me work as quickly as possible, right? So I remember, like, I always hated the guy who ran the Subversion repo. And like that for me was what like distributed version control was like, you know, it made it easier for me to like do commits locally and then push them. And yeah, maybe we'll sell code reviews and things like that, but it really made it a lot easier. You didn't have to go through so many manual things. It was all automated. I think, you know, deployments is a good example of this. Like, well, this whole concept of going from dev to prod, like a deployment was a big deal.
Yeah.
And now something like Vercel, it's not as big a deal. But what are other things, like, imagine this paradigm continues forward and you're a developer and you want no one getting in your way. You want like no ops, not just DevOps. Where are there still bottlenecks to developer in the world of Next that, you know, people need to work on? And I have some ideas, but I'd love to hear this.
So when you pitch VCs, I'm told you're supposed to link up a bunch of stuff. Grand ideas. So I remember when we were trying to reverse engineer our mission and focus kind of stuff, the hypothesis was going back to that canary thing. It's like, well, what if you could run version 1, version 2, and you could fully shadow traffic on both? Hopefully it's not over everybody's head, but so somebody hits Walmart.com, that exact traffic goes to beta.walmart.com or something like that, right? Same code bases, or same infrastructure, different code. Customer sees version 1 that's stable, but the monitoring system sees version 2. And so then you basically got free QA, right? Like it's fully automated, machine-driven QA. The tools can figure out if something's wrong. That is a really interesting idea. The reality is databases are not that easy to work with. And even if you use something like Next today or Vercel even, or even Heroku. Like Heroku tried, but like where's the database live? It's a stateful machine. It requires complex security and authentication. Like there's 15 different databases at any given moment in time that you want to use. And like there's not really third-party services that host them. And even if there are, they're not inside your cloud. So latency is a problem. So there's like, state is still a problem.
Yeah.
So even though like CDN is a CDN, it works phenomenally well, we can make it faster and faster and faster, but state is the problem.
Yeah.
And I don't see that changing anytime in the near future. And I know there's a lot of investment around services, but if you've ever tried to use Firebase, it's not fun. The database, the NoSQL database is impossible to write securely, like the rules and stuff behind it. And so it's like an interesting academic idea, but I just don't see anything coming anytime soon.
I think the state's, I mean, I always think about one of the examples I remember, and I was never a very good developer, by the way, so it should be disclaimer. But I remember the first time I had to care about like connections in a database. And I still think to myself, like, why is that like a thing? Like, I know why it matters, but like most developers shouldn't have to think about connections. And that's still a huge issue. And it's even exacerbated in kind of the world of front end where, you know, I'm a front end developer, you have way more connections potentially. It's a huge challenge. There's security issues, but there's also just like too many connection problems. And there's got to be a way to kind of deal with that, whether it's middleware or databases that kind of incorporate that. I think one of the coolest things about things like Vercel and Next and this like kind of CDN caching model you mentioned is, yeah, you get the data everywhere the users are, or sorry, you get the app everywhere the users are. But now you're sitting there and you're still waiting for data to load from US East or something in Northern Virginia, even though it's cool that your app's somewhere else. So there's like a lot to be solved there. I also think there's a lot of opportunities. You mentioned the shadow traffic example. You know, one thing the most sophisticated companies do that I think is a huge opportunity is, you know, everyone hates long builds. Like nobody like a huge part of this is if you're going to do builds and pushes and deploys every time, you don't want your builds to take forever. And you can do a bunch of like statistical ML analysis on like what tests do I need to run. If you have a massive failed test, you just want to make sure that test runs first. And there's lots of ways you can kind of intuit that. But one is like based on like kinds of traffic that you're getting. One is based on prior tests that fail. One's based on what part of the code base you're doing. And you know, the biggest, most sophisticated companies like Google and Facebook do this. But there's a huge opportunity for it to be done for everyone else. And a lot of it is like, do we have like a unified tool set? Do we have unified application frameworks? Do we have great build systems? And so I think there's a lot of...
yeah, I mean, it goes back to tool chain. It's like we change a tech and we have to reinvent all the tooling along the way. Now, the problem usually is the people reinventing it did not invent the first version, and so they're relearning all the same mistakes. Like This was a big pet peeve of mine when like Node and JavaScript was up and coming. You had people inventing like logging libraries. And they're like, well, we don't need log levels. It doesn't even make any sense. And these people had never written like server-side code before, right? And then, you know, over time they figure out like, oh, maybe we need to introduce log levels, or oh, we need to introduce named loggers, or all these other things. I'm like, there's prior art. You could have just like tried to understand why it exists, you know? And so I think even like the build systems and stuff, that's kind of the thing. And it's nonstop stuff has to change and adapt along the way, right? And like every few years, there's some cool new idea, which is important. It's innovation, but there's the cost of every new idea. And actually, I think this is React's strength. Like there was Angular, there was Ember, there was React. We wrote Sentry in all three of those, the front end. We stuck with React. And we stuck with React because it was the least compromise. Like it was not super opinionated. It was very fast. It did everything we needed it to do. And it was run by a big organization that wasn't going anywhere. Facebook, you can love them or hate them, but they've contributed a lot of great stuff. So, and I think React's great. I hope things like React stick around. But I think things like React are so great because they're based in like the fundamentals of the problem that needs to be solved versus like, here's a fun, shiny, cool idea, right? And I think, you know, Next does a lot of this cool stuff. But I think Next challenge is like, I've got to build my app differently than I'm used to, which is like Ember and Angular's challenge, to be fair, too. Now, Next doesn't compromise in the same way that they do. But I think it's still like, you've got to change how you're building the app, which means you got to change how you test the app, how you monitor it. Like, the whole life cycle changes. And it's like, you know, I think they'll converge, to be fair, at some point, and everything ends up looking the same if it succeeds over time. And I think part of the attraction is the technology moves us forward in sort of solving some of these experiences, and we get to solve some of the problems along the way, which gives you the option to rethink things. But the consequence is, like, it doesn't necessarily work for everything yet. Like, there's a lot of problems that are, the database thing is the real problem. Like, if you want to build something like Sentry, you could probably build it in Next.js. You probably couldn't build it on Vercel, however.
Not yet.
Because you need a database. The database has to be lightning fast, right? So I think it's like, you know, works for some things, doesn't work for others, but that's totally fine as well.
Yeah, and it's a big opportunity for folks to do more of these third-party services and things like that around. So there's a huge shift happening, and there's lots to do. Well, anyways, David, thank you so much for sitting down and talking about this stuff. It's super valuable. And everyone should go check out Noe Valley Astronomer, and feel free to troll David about it. But it's some pretty cool stuff.
I have no idea what I'm doing. So.
He's doing a great job. All right. See you later.
E-commerce is driving one of the largest and fastest global economic transformations in human history. BigCommerce is a software-as-a-service platform that powers 60,000 of the world's most interesting and beautiful e-commerce stores. We provide everything that a business needs to create, manage, and grow an online store. From the design of that store to the infusion of product catalog, the checkout, and all of the tools that help you market and grow. Our mission ultimately is to help our customers turn their long-term digital transformation into competitive advantage.